warm welcome to this platform. In this video, we are going to go through organic chemistry questions from 2016 to 2023. In total, there are about 24 questions that we are going to answer. So if you have challenges in organic chemistry, stay up to the end. You are going to understand very well. As we go along, I'll get to explain some concepts. But before we start, let me run you through the programs that we have. So we offer online tuitions in the following categories, that is grade 10 to 12 and GCE, that is for ECZ. We also offer IGC SE, Cambridge, and A level. The subjects available are the following: mathematics, additional mathematics, physics, chemistry, and biology. Okay, so these are the subjects that we offer. If you want to enroll with us, get in touch on the number 0976-402563 and we'll get in touch. Alright, let us begin. And the first question that we are answering comes from 2022 GCE. And the question reads, 3 hydrocarbons given are members of a homologous series. So a homologous series, you can just look at a family, belong to a family, okay, are members of a homologous series. Now, these 3 hydrocarbons that we have are CH4, C4H10, and C10H22. So now the first question is that explain the term hydrocarbon. Explain the term hydrocarbon. So the term hydrocarbon, you can define it as a compound that contains carbon and hydrogen only. As the name suggests, hydrocarbon. So it's simply a compound that contains hydrogen and carbon only. So that is how you answer this question. And this question was only 1 mark. So for writing this, you are given a mark. Then name one, the homologous series to which the above hydrocarbons belong. So now, where do they belong? Now, if you look at the general formula, let me just write the general formula for the 2 hydrocarbons that we can look at, just 2 possible ones. CnH2n plus 2. Then we have CnH2n. This is alkenes, or this one is for alkenes, this one is for alkanes. Now look at this. If we are to look at this, what is happening? The number of carbon is 2. The number of carbon is 4. Her number of hydrogen is what? Is double the number of carbon, but plus a 2. What I'm saying is that the number of carbon is a 4, but here there's a 10. From this, you can see, from this, carbon 4, if we are to put, because this N represents number of carbon. So if you have 4 carbons here, 2 multiplied by 4 plus 2 is a 10. Also, if we are to try out this one for 10, if we are to put a 10 here where there's N, then 10 multiplied by 2, it is 20, plus 22 gives us 20, plus 20, 2 plus 20 gives us a 22. And this means that these belong to alkanes as a family. So that is how we can simply identify them. But for alkene, it's just double. So it was going to be 8, this one was going to be 20. Okay, so these belong to alkanes. Okay, so the family or the homologous series is alkanes, or belongs to alkanes. The second question, that is of B, name the compound with molecular formula C4H10. What is the name of this compound? Now, from where we are coming from, for those who have not viewed the topic, the part that we learned, on which we learned about this, if you don't know, a hydrocarbon with 1 carbon is called a meth, that is a prefix. The first part of the name is a meth. Those with 2 are called eth, that is 2 carbon, eth. With 3, prop. 4, bute. So I'll end on bute because we are looking at the one that has 4. But you can go on 5, pent, that is the prefix. 6, we have hex. 7 is hept. 8 is oct. 9 is nan. And 10 is dec. Okay, these are the prefix, what you put at the first part of the name. Then now it depends, are they alkanes, alkenes, or what? If they are alkanes, then at the end you just add en, that is A-N-E. If alkenes, you add E-N-E. If they are alcohol, you add O, okay? That is ano, okay? If they are carboxylic, you add anoic, okay? That is to this name. Then you add, so that is what you do. Now, for this one, since you know that we've established that these are alkanes. So now, what is the name for this? So, how many carbons? 4. So this one is going to be butane, okay? So the name to this, or the name of this, is called butane. Okay, so that is the name. Then C, draw the structure, draw the full structure formula of the hydrocarbon which has 4 carbon atoms. So now this one that we've named, which is a butane, here they are asking us to draw the full structural formula. Now when you are asked of the full structure formula, just know that you need to show the bonds, how these hydrogens are bonded to the what? To the carbon. You need to know that carbon form 4 bonds. And therefore, to write the full structure formula, you are going to start by connecting the what? The carbon chain. You are going to start by drawing the carbon chain. How many are they? 4. So you connect carbon, 4 of them. Okay, like this, you connect 4 of them. Then now to each carbon, you know that there's supposed to be 4 bonds. So this one is already bonded to this one. So only remaining with the 3 bonds. This one only remaining with 2. This one only remaining with 2. This one only remaining with the 3. Therefore, you are going to connect the hydrogens now here. Okay, because this is a hydrocarbon, so which means you only find hydrogen and the carbon. Okay, so you connect like that, you connect like that. So this is the full structure formula of the hydrocarbon, which has 4 carbon. So this is the answer. Then the second, the D question is, to which of the given hydrocarbons, or which of the given hydrocarbons has the highest boiling point? Which of the given hydrocarbons has the highest boiling point? Now, remember, we are answering this question still. That is question 1 that we are looking at. So they are asking us, of these 3, which of these has the highest boiling point? Now listen, in terms of hydrocarbons, or this applies to all, as the number of carbon increases, the boiling point, the melting point, the density, all that increases. So this to mean that this one, if we are to compare this one, that is the first one, and this one has the higher boiling point. If we are to compare the 3, the one with the highest boiling point is this one. So what are you going to write here? The one with the highest boiling point is C10H22. So that is the answer to this question. Okay, up to the next question, that is the second question. So for this question, I've not indicated the year because I modified the questions in trying to cater all parts of the topic. So some of the questions I was modifying them so that can cater all parts of the what? The topic. Okay, so now, what is the first question? Or what is the question? Petroleum is the complex mixture of hydrocarbon. Petroleum is a source of many useful fuel. So I must indicate that petroleum, also known as crude oil, it contains about hundreds of components, which are called fractions. Okay? So, as they are saying, it's a component of many useful fuels. Now, the first question here is that, what is a fuel, or define a fuel? So, how do you define a fuel? So, a fuel is just a substance when burned produces heat energy. A substance when burned produces heat energy. That is what we call a fuel. So that is it. Then the second question is that, what is meant by the term hydrocarbon? So this one we're not going to go through again because we've already answered it in the first question. A hydrocarbon, we said, is a compound that contains hydrogen and carbon only. That is how we define a hydrocarbon. So up to B question, the petroleum is separated by fractional distillation. Name the fractions with the highest boiling point. with the lowest boiling point first, then we come to the highest. So petroleum is separated by fractional distillation. Name the fraction with the highest boiling point, with the lowest boiling point. So the one with the lowest boiling point in the separation or the fractional distillation are refinery gases. Okay, so the answer we are looking at refinery. Let me write it nicely. Refinery. Okay, refinery gases. So this is the answer. Okay, then with the highest boiling point you find bitumen. Bitumen, written as this, or asphalt. That is the answer. Then the question C, state the use of petrol. State the use of petrol. Okay, so petrol worldwide is normally used in car base. That is the common use. I'm not saying that is the only use. But if you are to give the use, so for this one I'm going to go for petrol based cars. It is used as fuel. So I'll say used as fuel for petrol based cars. So there are wide uses. Okay, so you can look at different uses, but in this one I'll use petrol based cars. It is used in different. Okay, others are use it in generators. I guess there are, gensets. There are those that use petrol. So quite a number of uses that you can talk about. But in this case, since you are just required to give one, I've gone for this one. But be free to go for the one that is at the fingertip. Then, what is the use of paraffin waxes? So paraffin waxes, we are going to look at used in making what? So for me, I'm going to go for used in making candles. Candles, what else? Cosmetics. Cosmetics. And of course, polishes. So you can go on and look at other uses that you can look at. Remember, we are looking at paraffin waxes. Okay. Let us look at the other part. That is the D question of question 2. An alkane molecule is cracked and yield the two molecules. Okay, so when an alkane molecule is cracked, these are the two molecules that are produced. What is meant by the term cracking? What is meant by the term cracking? That is the first question. So this question also, so please pay attention to the questions that we have. As we go on, you are going to find that they are all a repetition. So questions will be repeated in different years. Okay, so what is cracking? So cracking is just a breaking down of larger, heavier, and of course more complex hydrocarbons. So I can write is the breaking down of larger, heavier, let me just write nicely, heavier and complex hydrocarbons into smaller and lighter, into simpler or smaller and lighter, or let me just say into smaller molecules. Okay, so cracking is just a breaking down of larger, heavier and more complex hydrocarbon into simpler and lighter molecules. You can add that. That is what you call cracking. There are two types of cracking. So the second question is that state two types of cracking. So one type of cracking is called thermo cracking. Now, thermo cracking involves the use of large amount of, or it involves the use of what? Heat. That is what you call thermo cracking. So thermo cracking uses heat to break down these larger and heavier complex hydrocarbon to smaller ones. But we have also what we call catalytic what? Cracking. So these are the two types of what? Cracking. So take note. Two types of cracking, thermo cracking and catalytic cracking. Okay, what is the other question? Write down the two possible products when the compound C1122 was cracked. So when this one is cracked, it is going to be broken down. You're saying two possible. So in writing 2 possible, you need to make sure that at the end, so we have CH, that is C11H24. So whatever products that you are going to come across or to come up with, at the end should have, when you add them, like this, the one that you are seeing. So these that you are seeing here, the 2, the compound in which they are cracked, you just add number of carbons, how many are they? So it's going to be C8. Then number of hydrogens, 12 plus 6 is going to be what? 18. So it's going to be 18. So what I'm trying to say that the products that you're going to come up here, or the possible product, should add up to what is given here. So what if I say C4H8? Okay, then what is remaining out of from the 11? What is remaining? You are remaining with C7H24 minus 8. What is remaining? 16. Okay, so if this one, we say if this one was these 2, since we are saying these are the products of cracking, these 2. Now, if we are to go back and we asked to write the original compound from which these 2 were cracked, you just add number of carbons, how many? C8. Then number of hydrogens, what is the total hydrogens? 18. So C18. So these 2 products came from this compound when it was cracked. Now here we are given the compound, then they are saying what are the products if it was cracked. So if it was cracked, I would say C4H10, H8, and this is called butene. Then also what will be produced is C7H16, and this is called heptane. Okay, so an alkane and an alkene is produced. So these are my 2 possible products. Now when you give the product at the end, they should conform to the hydrocarbons that we have, that is alkane and alkene. So you need to check with the general formula if they are conforming. Okay, so mine that I've come up with, this one is going to conform to this one, because if I put a 4 here, it is going to be 8, and hence this one conforms to this one. This one, if I put a 7 here, 2 multiplied 7 is 14, plus 2 is 16. So also this one conform. So you shouldn't give anything that is outside of these. For example, let's say it was C5, then H11. Okay, if we were to try out this one from these, it will not balance. You've seen. So that is how you come up with the products of cracking. Okay, so the second question is this one. The fourth question rather. So the fourth question after the possible product is give 2 reasons for cracking. So what is the reason for cracking? Now look at this. Cracking is a breaking down of large molecules into smaller ones. Now, why do we need to break them into smaller ones? Now, for you to know, the smaller molecules have or are in high demand, because petrol you find it in that range, diesel you find it in that range in the smaller molecules, and look at its wider use. Now, if we look at bitumen and all that, they are not much used. Normally, they are used in making what? Tarmacs. But look at their use. Petrol, diesel, normally in our everyday life, we use them. Okay? In cars and all that. In short, they have wider use. Now, from that, we can derive the reasons why cracking is important. So, one is to convert the large hydrocarbons into smaller ones. To convert large hydrocarbons into smaller ones. So that could be the reason for cracking. Then the other one, to meet the demand. To meet the demand for smaller hydrocarbons. To meet the demand for smaller hydrocarbons like petrol. Okay? If you are in a country, Zambia, at the moment, we are locked with shortage of fuel hike, because there's low supply. Let me say there's low supply of that, and of course the demand is high, and hence prompting the prices to go up. So to meet that demand, there's need to break down these large hydrocarbons so that we can have a lot of these smaller hydrocarbons are variable. Okay, not only looking at petrol, because I've just given a practical example of petrol, but also other products that are small. Okay, so that is the reason. So to meet demand for small hydrocarbons, and of course look at converting large hydrocarbons into smaller ones. Okay, then question E, that is question E, describe how you would distinguish between alkanes and alkenes. Describe how you would distinguish. To distinguish, we are just looking at to differentiate. How can you differentiate an alkane and an alkene? Okay, so for this one, how you distinguish, one, I'll put the answers here. In terms of their taste, how do you test for alkenes and how do you test for alkanes? So, for you to know, alkanes, they are non-reactive. In short, they are saturated. Whereas alkenes, they're unsaturated. In terms of their bonds, you find that alkanes, they have single bond, but alkenes, they have a double bond, which can break and allow the attachment of atoms, okay, to it, making it reactive. So we are going to look at it in terms of their testing. So alkenes, we can say alkenes decolorize bromine water. Okay, bromine water. Bromine water is red in color. When put, or alkenes are put in bromine water become colorless. Okay, so alkenes decolorize bromine water, whereas alkanes do not. Okay, so whereas alkanes do not. Then what is the other one? Alkanes have a functional group. Alkenes have a functional group, whereas alkanes do not have. Okay, so these are the two differences that we can look at, but quite a number of them. Do not limit yourself onto these. So one is that alkenes decolorize bromine water or bromine solution. Like I said, bromine solution is red in color. When alkenes are put into the bromine solution, it turns colorless. And of course, the reason behind that is that the reaction takes place, that is halogenation, where halogens attach to alkenes. So that is the reaction that occurs. Okay. Then the last question here, that is question number F. Draw the structure formula of one alkane and one alkene. Give the IUPAC name of the alkene. Okay, so draw the structure formula. So we are going to draw it from here. Draw the structure formula of an alkane and one alkene and give the IUPAC name of alkene. So I'm going to draw the simplest alkane, the structure, which is for C4. The structure is C with 4 hydrogens around, like this. Okay, then for an alkene, let me put up the structure. I hope I can put the structure. So I'll just remove this. I guess you know what to do. So I'll put up the one for, that is alkene. I'll draw propene, which is Z, 3 carbons. So between the 2 carbons, there should be a double bond. So since there's a double bond, this one is bonded already to 3. So it only needs 1. Remember, carbon bonds to 4 bonds. So this is hydrogen. That is, here is no hydrogen. Here is hydrogen. Here is hydrogen and hydrogen. Okay. Now, giving the IUPAC name of this, you just look at where the double bond is. It's a propene here, but is written as it's written as prop dash 1 in. Why is it written so? This is a propene, but the double bond is at carbon 1. So this number represent one carbon. Okay, I mean the double bond at one carbon. So prop-1 in. So this is the name to, or the IUPAC name of this alkene. Okay. Then the third question, that is coming from 2022. Start the following series of reaction of ethene. Here it is ethene, please. Start the following series of reaction for ethene, because it is not alkane. I mean ethane, because ethane is an alkane, and alkane, of course, they are non-reactive. So this is ethene. So look at the series of reaction. Or where it is starting from is here. So this is how you trace the reactions that is or that are occurring here, starting from right here. So now you can see ethene, add bromine solution or bromine water. Then what happened? Liquid F is formed. Then when this ethene or this ethene, you add gas A, it forms ethane. And when to this ethane you add gas C, it forms chloroethane with a condition D. Then this same ethene, it forms gas B and plus steam, that is in excess oxygen, and ignite. Okay. Then this same ethene, when added, or when you add steam, it forms liquid E. So you can see the reactions that are occurring. So here the reactions that are connected to this ethene, there are 4 of them. 1, 2, 3, 4. So these are the reactions that it undergoes. Okay. Now also this ethane, which is an alkane, undergo a reaction to form chloroethane. Now the question is, identify gas A. So what is gas A? Now look at this. Ethane or ethene, what reaction result into, or that convert ethene to ethane? In short, alkene to alkane. What reaction is that? So this can only be possible, or this reaction is hydrogenation, or the addition of hydrogen to ethene or to alkene convert it to alkane, and in this case ethane. So what I'm trying to say is that ethene is converted to ethane by the process called hydrogenation. That is the addition of what? Hydrogen gas. So the gas A here is hydrogen. Okay, so gas A is hydrogen gas. Then now, hydrogen gas, the process is hydrogenation, please. Let me just write also the process in case we find this question again, hydrogenation. Okay, then gas B, what is gas B? Where is gas B? So if I were to look at gas B is here. Now look at this, ethene plus or in excess oxygen. In short, when you ignite or burn, it produces gas B plus steam. This is called combustion. So combustion reaction or ethene undergo combustion reaction. In this case, what is produced? Gas B and steam. Now, generally, ethene or alkene undergo combustion reaction to produce carbon dioxide and water. That is in plenty supply of oxygen, or excess supply of oxygen, or full supply of oxygen. So here, since they are saying or excess oxygen, it means it is in a full supply or plenty supply. So what is produced is carbon dioxide and water. Now, since this occurs at high temperature, this is called, or this is in steam form. So in short, gas B is carbon dioxide. Okay, carbon dioxide is gas B. Okay, and this process, please, is called combustion. This is combustion. Then now let us look at gas C. What is gas C? So gas C is right here. Ethane, gas C, it forms chloroethane. Now look at this. The front part of the name talks about the gas C. So chlorine, when it reacts, it becomes chloro. If it was bromine, it becomes bromo. If it was iodine, it becomes iodo. So this is how it flows. So this is this gas already, you know, that is what? chlorine. So gas C is chlorine. Okay, now what is the process by which this one is formed? This is called halogenation. Okay, halogenation, not hydrogenation, halogenation, the addition of halogen to ethane. And of course, it's a substitution reaction. Let me just put substitution reaction. Okay, substitution reaction, of which is called halogenation in this case. Okay, now what about condition D? What is condition D? So condition D, halogenation or substitution reaction occur in the presence of UV light. So this is the UV light. That is condition D. So UV light. Of course, you can also put high temperature for UV light. Okay, what about liquid E? What is liquid E? So ethene plus steam result into liquid E. Now, what is liquid E? So steam, we are looking at water. Okay, so now the addition of water to ethene or to an alkene is called hydration. So this is hydration reaction. So hydration reaction results into the formation of liquid E. And in this case, since we are dealing with ethene, the liquid that is formed is ethanol. Okay, so ethene or alkene plus steam or water result into the formation of alcohol. The alcohol form depends with the alkene involved. So in this case, is ethene, it becomes ethanol. So liquid E is ethanol. Okay, so liquid E is ethanol. The process is hydration. Okay, and of course you need to know even the conditions that are involved in all these reactions. Okay, so now what is the name of, that is, we are up to the V question. That is this one is 1, 2, 3, 4, 5. Okay, this is a 6th question. So what is liquid F? Where is liquid F? This here. So now here what is happening is that ethene added, you add to ethene, you add bromine water. Now bromine water has bromine in it. Okay, has bromine in it. So it is bromine that react now with ethene. Okay, so bromine, when it react with ethene, what happens is like this. So ethene written like this, this is ethene. Then now to it, when you add bromine, what will happen? By the way, this double bond break and leave attachment for 2. You can put the bromines here. Okay, one here. Let me just put, when it breaks the double bond, it's going to leave room for bromine to attach. So one bromine will attach here, then here carbon, another bromine there, then we have the hydrogens here, hydrogens like that, hydrogen like that. Then now, what is the name of this? That is the question. What is the name of liquid F? So liquid F is going to be, look at where the bromine is. If I were to count from here, this is carbon 1, this is carbon 2. If I were to count from here, still be carbon 1, carbon 2. So there's bromine at carbon 1, so you're going to say 1, comma. There's also bromine at carbon 2, comma 2. Then dash. How many bromines are they? 2. Dibromoethane. So that is the liquid that is formed there. 1, 2, dibromoethane. Okay. Okay, so up to the next question, that is B. Write the balanced chemical equation for the reaction of ethene with excess what? Oxygen. Write the balanced equation for the reaction of ethene with excess oxygen. So in short, they are asking us to write the combustion reaction that occur. So in this combustion reaction, which is this one, write the balanced chemical equation. So we are going to write ethene H4, which is a gas, then react with what? Oxygen, which is a gas. Then what is going to form? Carbon dioxide, you know already that is in excess, that is a gas. Then plus a steam, which is the H2O. Okay, so what is remaining is for us to balance the equation. For us to balance the equation, So for us to balance the equation, how many carbon do we have this side? We have 2. This side we only have 1 carbon. Then oxygen we have how many here? 2. This side we have 3. So we can start by putting a 2 here in front of hydrogen. Hydrogen 4 here. Oxygen, 2 multiply oxygen, that is 2 oxygen, plus 2, 4 oxygen. This side you only have how many? How many oxygens? You have 2. But look at the carbon, it's also 2. What about we put a 2 here in front of carbon? So carbon 2. Oxygen has changed 2, multiply 2, 4, plus this 2, 6. So oxygen this side only have 2. We need to have 6. So we put a 3 here. So this equation has balance, and that is the balanced equation for the combustion of ethene. So that is how you write. Okay, then the C question, give the structural formula of liquid E. Give the structural formula of liquid E. Write the balanced O. Where is liquid E? So liquid E is right here. Now liquid E, I said, when ethene or an alkene generally react with or undergo hydration reaction, it results into alcohol. And in this case, since we are dealing with ethane I mean, the liquid that is formed is ethanol. So we are looking at the structure now for ethanol. Ethanol is an alcohol. Now, one thing to know is that an alcohol has a functional group OH, okay, or a hydroxyl. Okay, so now how are we going to write it? So we are going to draw it like this. Since we are drawing the structure, so we are going to show the bonds. But before then, let us write the molecular formula. So it's going to be like this. That is ethanol. Oh, this is 2. This is 5. Then OH. Okay. By the way, the general molecular formula, in the case where we'll be asked to write the general molecular formula of the alcohol, is CnH2n plus 1 OH. Okay, OH like this. So since you are looking at the one with 2 carbon, just put a 2 here. This is 2. Then 2 multiply 2, 4 plus 1, 5. Then OH. That is where this one is coming from. So now let's draw a structure. So we are going to have 2 carbons. To each, 1 OH is attached. Then hydrogens, 5 of them. You know that carbon form 4 bonds. Never forget that. Okay, so like this is the structure. Then for D, state the industrial application of the reaction with gas A to form ethane. So what they're asking us is the industrial application of this process. Okay, the conversion of ethene to ethane, of which we can look at the conversion in short in general, the conversion of alkene to alkane, which is hydrogenation. What is the industrial application? So this at industrial level, it is used in converting vegetable oil into margarine, or in hardening vegetable oil to form margarine. Okay, so used in hardening of vegetable oil to form margarine. So that is one of the application. Then it is also used to improve the oxidative stability of oils, okay, and also used in petrochemical industry. So 3 of the uses: 1, hardening of vegetable oil to form margarine; improve oxidative stability of oils used in petrochemical industries. So take note of those uses. Okay, so up next is question 4. That is coming from 2022 GCE. Okay, now the first one, we had also the one that's coming from 2022, and of course here again 2022 GCE. So now the thing is that one is coming from section B and the other one is coming from section C. So let there not be confusion. Okay, so this question reads: propene is one of the main important hydrocarbons obtained from crude oil. Like propane, it is made up of molecules which contain 3 carbon atoms. draw the structure formula of propene. So this one is simple. So propene, you just draw how many carbons? You know that is 3, but at least, between 2 carbon, I mean, there should be a double bond. So 1, 2, 3. Between 2, I can put a double bond here, which means this carbon is already bonded to 2, and therefore it only needs how many? 2. Then for this one is bonded to 3, only needs 1 hydrogen. This one bonded to 1 needs 3 hydrogen. So it will be written like this. Like this. Okay? So this is the propene. Then how does propene differ from propane in terms of bonds? So this one more like we looked at this similar kind of equation. The difference is in terms of the bonds. So in terms of bonds, propane has a single bond since it's an alkane. Then propene has double bond. So propene has a double bond, while propane has single bonds between carbon. Okay, so between carbon, propene has a double bond between carbon to carbon, and of course this one has a single bond between carbon. Okay, to which group of hydrocarbons does propene belong? So it belongs to alkenes. Give the molecular formula for propene and propane respectively. So give the molecular formula of propane and propene respectively. Now this one you can derive it from their general molecular formula. This is for propane, this is for propene. So for propane you just put a 3 here, since it's 3 carbon, just put a 3 here. Therefore for propene it's going to be C3H, 3 multiplied to 6 plus 2, 8. Then for propene is going to be, since it has 3, from this formula, C3, then H6. So this one is for propene. This one is for what? Propane. Okay? Explain why propene reacts immediately with bromine solution, whereas propane does not. So from where we are coming from, we looked at that general reaction, or that reaction scheme, where we discussed the reaction of ethene, which is an alkene. So alkene, they do behave that way. So now here the reason is that, why does ethene react immediately with bromine solution, whereas propane does not? Okay, so propene has a double bond. Propene has a double bond between carbon that breaks and leave room for attachment of bromine. Okay, so the double bond breaks and of course leave room for attachment of bromine, whereas propane, they do not have, or they are non-reactive in short. So that is the reason why it react immediately with bromine solution, because bromine, as we said, it contains bromine. So bromine solution contains bromine. So bromine from the solution react with propene, because of this double bond. That is how you can look at it. Describe what would be observed during the reaction. So what would be observed during the reaction is the identity test now for alkenes. What happens when alkenes, or when bromine solution, bromine water is added to alkenes? Generally, they decolorize bromine solution. So therefore, the observation is that the bromine solution will turn colorless. Okay, will turn colorless. Okay, Then propane is obtained by breaking down large chain of hydrocarbon. What is this process called? So this is called what? Cracking. Then propane is a monomer for making an important plastic. State the name of the plastic it forms. So what is the name of the plastic that propane forms? So it is called polypropene. Okay, polypropene, which is a synthetic fiber. Okay. Let us look at now question 5. So for question 5, it reads, a hydrocarbon V which contains only 3 carbons. So we know that the hydrocarbon V contains how many carbons? 3 atoms. Was bubbled through bromine solution, and there was a rapid decolorization of the solution. So now, just from the process itself, you can tell that even if you don't know the name, or we don't know the name of this hydrocarbon that has 3 carbons, but we know for sure that this is an alkene, because alkene generally are the ones that decolorize a bromine solution. So just from that statement, you're able to tell that this is an alkene. Now, an alkene with 3 carbon is called propene. Okay, so we've identified it already. So the first question is, identify the hydrocarbon V. So what is the hydrocarbon V? The hydrocarbon V is called propene. So propene is the hydrocarbon V. Draw the structure of hydrocarbon V. So in short, draw the structure of propene. Now, if you are told to draw the structure of a hydrocarbon or a compound, it means that you have to show the bonds. Now, for sure, this one is the 3 carbons, and you know that alkenes, they have a double bond between 2 carbons. So 3 carbons between 2, there's a double bond. So you're going to draw. Normally, when you are drawing the structure, please, you start by putting up the carbon chain. So carbon chain has how many carbons? 3. And you know that between, there's a double bond. This double bond can be here or right here. Okay? So now, you know that carbon bonds to 4 bonds. It forms 4 bonds. So this one remaining with 1, a shortfall of what? 1. This one remain with a shortfall of what? 2. Okay? Then this one remain with a shortfall of what? 3. These are hydrocarbons, so which means the hydrogens are the one that attaches to the remaining what? Part. So this is how propene appears. Okay. Next to the question, or let us go to question 3, that is of A. To which homologous series does this hydrocarbon belong? Since we said this has a double bond, and therefore the hydrocarbon that has a double bond are called alkenes. Okay? And at this point, you should know that the double bond is a functional group. Now, what is a functional group? Maybe a bit before we even proceed. A functional group is just a group that determines the reaction of the compound. And this is the reason why alkenes or alkanes are not reactive, because they do not have a functional group, although they undergo certain types of reaction. But for this one, is reactive because of this functional group, which is a double bond. So take note of that. Okay, so what about question 4 on this A? Write the general formula of the homologous series where this hydrocarbon belong. So if you are told to write the general formula of the hydrocarbon or the homologous series, the family to which this one belong, you are simply looking at the general one from alkenes. And what is that? Is CnH2n, where n is the number of carbons. So number of carbons. Okay? And of course, you should know that the first alkene, or the simplest one, has 2 carbons. There's no alkene that has a single carbon. So take note of all that. Take note of that point. Then for B, explain the dangers of burning hydrocarbon V in limited supply of oxygen. So in short, here we are told to explain the dangers of incomplete combustion of hydrocarbon V, because in limited supply, it means that it does not burn completely. So the terms that are used, please, in limited supply and shortfall supply, it all mean one and the same. But the other way that can be used is full supply plenty supply, or excess. So these three: excess, plenty supply, full supply. It means a lot of oxygen. And now in that one, the products that are produced is oxygen, carbon dioxide and water. But in limited supply, the question that we are answering, the products that are produced is carbon monoxide plus what? Plus water. Now the dangers of this is that it produces the dangerous gas, carbon monoxide. It produces the dangerous gas, carbon monoxide, which destroys brain cells. So, produces a dangerous gas, carbon monoxide, which destroys brain cells. So please take note of that. Carbon monoxide destroys brain cells. In short, carbon monoxide has the high affinity for oxygen, and therefore it binds to hemoglobin and transported to the vital organs, the vital parts, and of course instead of oxygen. Now other parts are deprived of oxygen. What happened to the cells? They die because of lack of oxygen. So that is how basically it destroys the brain cells. So that is something that you should take note. Okay, so we still on this question. Write the balanced chemical equation for the reaction in B1 above. Now, in B1 above, we have incomplete combustion. So we are simply writing the incomplete combustion of, that is propene. So how is it going to be? So propene written as C3H6, okay? It reacts with oxygen to form what? What is going to form is the carbon monoxide, then plus what? Plus water, okay? Plus water. Now, balancing the equation, we are just looking at the atoms on the reactant, which is this side of the arrow, should be equal to the ones on the right side. You know that the atoms that are involved on the reactant, on the product, are the ones that you're going to find. So they should be balanced in terms of numbers. So here you have how many carbons? You have only 3. This time, this side you have 2 carbons. This side you have 6 hydrogen. This side you have how many hydrogen? 2. So hydrogen, carbon, even oxygen is not balanced because this side you have 2, this side you have 1. Let us put a 3 here. Hydrogens you have 6, hydrogen 6, oxygen 3 plus 1, 4. What about carbon? Carbon is not balanced, so we put a 3 here. So 3 carbon, oxygen this time around, or this side has become 6 because 3 oxygen and 3 oxygen, so 6. Carbon 3, hydrogen 6. This side, oxygen we have what? 2, so we put a 3 here. So oxygen 6, so the equation is balanced. So this is the balanced equation of the combustion reaction of the propene. Okay, so that is how basically write it. Now, you need to know when, if they are talking of plenty supply, limited supply, or short for supply. Short supply, limited supply, one and the same. In all cases, the product is the carbon monoxide and the water. In plenty supply is carbon dioxide plus the water. All the alkenes, that is the way it is. Then for C, under suitable condition, the hydrocarbon V was polymerized and the polymer W was produced. Display the structure of polymer W. So now we are saying under suitable condition, the hydrocarbon V was polymerized and of course the polymer W was produced. Now let us put this one into structures. So we have propene like this. Let me just try to explain something here. We have propene like this. Okay, let me put carbons. This one is going to serve as an explanation to every question that we are going to find on that is polymerization. And of course, the kind of polymer that is formed is called additional polymerization. So, in this case, let us look at propene and propene. Okay, forming a polymer. So, how is it going to be? So, we have this propene and of course another propene forming a polymer. So this is the propene and of course again this is the what? Propene. and this is called additional polymerization, please. Now, what is going to form? Because here they've just told us, they've not told us the number. So in most cases, in other cases, you're going to be told, okay, show, let's say 3 repeating units. These are called monomers. Show, okay, 3 monomers of the product. But in this case, we've not been told. So which means we are just showing how it is going to happen generally. So for example, if you have 2 propene that are reacting to form a polymer, what is going to happen? So please, in order for the polymer to form here, these are going to be, in terms of in relation to the double bond, this is going to act as a branch, and we are going to align it where it is going to come down here, and also this one as a branch is going to come down here. So in other words, this first part, we can write it as like this, okay, double bond, then we have carbon. Let me put this one down, C, this whole part here. C, it is attached to what? 3 carbons, 3 hydrogens to be C3, like this. Then this one I'll put a hydrogen, hydrogen, hydrogen. So this one is just the same as this one, okay? So want to see how, because the double bond is the one that break and of course leave some room for attachment here. So plus, and again this one I'm going to write it this way, hydrogen, hydrogen, then the double bond, then this one is going to be like this. So, like this. Then now what will be the resulting polymer for the 2, just the 2. So this one is going to break, and of course it's going to be like this. So this one maintains here, this one here, and of course there will be an attachment here. Okay, so equally this one is going to break. So it is this part and of course the other part that attaches. So the product is going to be how many carbons? 4 of them. So you draw 4 of their carbons, but at the end leave some room for attachment because these have broken. So here is hydrogen, hydrogen, hydrogen. Remember, on the second carbon there's this part, CH3, then hydrogen, which is this first part, and hydrogen. Then the second part there's this CH3. Okay, so this one is when you've shown now how many bonds, monomers, repeating units, 2. But in the case where you have a lot of them, you can just put these in brackets like this. Okay, let me just draw them nicely. Brackets like this, you put them in brackets like this. Then now here they should be extending from outside like this. Then you add number here. So this one can serve as the polymer that we are looking at, the display structure for the polymer W. Because we've not been told the number, so we can just put here the number, represent the number of units. If we are told 400 units, we are going to put a 400 here. But since we are just told the polymer W, so we can just leave it like this. So this one serves as what? The answer. So what you should know is how to align, to arrange these. They are not supposed to appear like this in terms of forming a polymer. So the double bond should be exposed where you align them like this, so that when it breaks, it leaves room here in the sides for attachment, and it appears like this. Okay, but in some cases you're going to find the question that is already given, and of course we should be able to go around that. So this is what you needed to draw. Okay, up to question 6. The question 6, let us answer question 6. So this one I've modified it because some of the questions I've just fused in it, so that at least we can have the wider part where it caters some angles of the topic. So what is the question? Butene, that is C4H, is a compound belonging or that belongs to alkenes. So here specifically they've told you that butene is a compound that belongs to what? Alkenes. State the general formula of alkenes. So this one is just a repetition of what we've answered. The general is CnH2n. That is the general formula for alkenes. Draw the displayed structure, or draw the formula or display the formula of the second member of the series. Draw the display structure of the second member of the series. Now, if we are to look at this, you need to be very careful. The member of the first member of the series has 2 carbons, which means the second has how many carbons? 3. The third one has how many? 4 carbons. There is no one that has 1 carbon. So that is very important to take note. Some of you might start from 1, or you might give ethene as the second one. So the second member has 3 carbons. So in short, they are asking us to draw the structure of propene, of which we've done already at some point, but we're just going to do that. So draw the displayed structure. So when they say draw the displayed formula of this, I mean the compound that has, or the second one in the series, you surely have to show the bonds. So in this case, you are going to say, or you are going to draw propene, I mean. It appears like this. So this one, there's hydrogen here, hydrogen there, hydrogen. Here is only 1 hydrogen. Here there are 2 hydrogens. Here there are 2 hydrogens. I guess you've understood what I said. Is that the second one? In this one, it is the third one. If we are to look at number of carbons, or it has 3 carbons, so it is at position 3 in terms of carbon. So you look at the first one to be ethene, the second one to be propene, the third one to be butene, fourth one to be pentene. So that is how you look at it. Then now the C question, butene is prepared by cracking petroleum oil. Name the other method by which it may be prepared. So another way, in short, how propenes, or how, I mean not propene, how alkenes are prepared aside from cracking. Yes, cracking is one way alkenes are prepared, or you can obtain alkenes. But what is the other way aside from cracking? So another way that you can look at is dehydration of alcohol. So here I'll put dehydration of alcohol. So when alcohol are dehydrated, that is water is removed, they return to, they become alkene. As you know, hydration reaction results into alcohol. That is addition of water to alkenes result into alcohol. So when you remove water, you are going back to the what? Alkene. So in other words here, since butene is an alkene, and therefore we can safely say is dehydration reaction. Okay? Then what about the D question? But1 can be polymerized. But1 can be polymerized. Now, this one for you to know, this one means that the double bond is at carbon 1. So if you are to draw butene, but1 is like this. So 4 carbons is going to appear like this. Okay, so around hydrogens, hydrogen, here hydrogen only 1, here 2 hydrogens. So it's going to appear like this one. The double bond is at carbon 1, so it is like this. Okay, let me just remove this part so that we decongest this area. Okay, so they are saying can be polymerized, and of course you know that they undergo additional polymerization. So name the type of polymerization it undergoes. So I've just given already. That is the additional what? Polymerization. Polymerization. Where the repeating unit, in this case, they keep on adding. Okay? So it's additional polymerization. Then draw and give the name of the polymer formed from but1 show at least 3 repeating units. You see? In this one, they've told you that show at least 3 repeating units. So which means you are going to draw at least 3 repeating units of butene. Okay? So now, how are we going to draw it? So you know that butene, the formula is drawn like this. C, double bond, like this. Okay? Let me just put it here, like this, as you can see, like this. So this is the carbon. This one only had 1 hydrogen. So please, you need to make sure that a carbon is attached to 4 bonds. So this carbon, double bond, plus 1, plus 2, 4. This one, 1, 2, 3, 4. 1, 2. So all the carbons should be attached, not more than 2. So not more than 4, I mean. So if you have to put another bond here, that is not true. Okay? So now, for you to form the polymer, I said you need to expose the double bond, where you rewrite this one. Okay? You realign this one as a group here. Okay? So this whole part, you are going to write it down here. And of course, it's going to be up, down. Okay, you write them up, down in relation to the double bond. So this butene, I'm going to rewrite it like this. Okay, it's going to be written like this before it forms even the polymer. So, like this, double bond. Then down here, you remember the other part, okay, the other part of butene, it was like this. It was like this, okay. It had how many? It had 2 carbons. How many hydrogens? 5. This part is the one that I'm interested in, okay. So it had how many carbons? 2. How many hydrogens? 5. Then up here, then here, then here, okay. That is but1 the way you write it, okay. But this one can also be written in other form where you put, let's say, the double bond, this branch here, another one. Okay, I'll show you that at some point. Let us focus on but1. So it's saying at least 3. So we are going to add another one, okay, another one drawn like this, 2, that is 5, up hydrogen, down hydrogen. Another one, since it's an additional polymer, so up hydrogen, down hydrogen, then here double bond, down the part, this part, which is C2H, 5, then up here, hydrogen. Now, what is it going to form here? It's going to form the compound that has how many? 3 of these. So now, in total, the chain, these they break, and of course, they are going to leave the attachment in these sides. So the total of carbon in the long chain will be how many? 6. So you're going to have 1, 2, 3, 4, 5, 5, 6. Then afterward, at the end, you leave the room for attachment of some more. Okay. Then here it's going to be hydrogen. Look at this. We just pick here hydrogen. Then here the second carbon is going to be hydrogen, but down it will be C2H5. Then here hydrogen, but here C2H5, here hydrogen, here C2H5. On top here hydrogen. So right here is the polymer of the but1 that contain or showing 3 repeating units. Okay, so what are the repeating units if we are to cut this one? So please, sometimes you are going to find the one that is already given. So you just have to cut them into repeating unit for you to determine the monomers. So if you are to cut it, this is the first part. If we are to cut it here, this is the second part. If we are to, okay, this is the third part. So this is the polymer showing 3 butenes. Okay. Now, what is the name of this polymer? It's called polybutene. Okay, it's called polybutene. That is the name. Okay. As the question, is there a question that is asking us about the name? So draw and give the name of the polymer formed from the but1. Show at least the 3 repeating units. So we've shown 3. So now this code, so we've drawn, so what we are interested in is drawing this structure, and of course we've shown the name is polybutene. So the name is polybutene, and this is the structure that we are interested in. Okay, so take note of that. So the name and the structure. Okay. Then the second, the question E, that is E1, butene react with steam in the presence of a catalyst to form a colorless compound. Name the compound what? Formed. So, when butene react with steam, steam is water, okay? So, when alkenes in general, when they react with water, what is formed is alcohol. So here, naming the compound that is formed, or the colorless compound that is formed, is what? Alcohol. And what is the name that is formed from butene? Is called butanol. Okay, so butanol is the compound that is formed. Compound formed is called what? Butanol. Write the balanced chemical equation for a reaction between ethanoic acid and the compound named above. So now we are writing the balanced chemical equation for the reaction of ethanoic acid and the product formed. So the product formed is butanol. So simply write the balanced chemical equation of butanol and ethanoic acid. Now one thing to know is that when an acid reacts with an alcohol, it forms an ester. So let us write the balanced chemical equation. So ethanoic acid is written as butanol is written as NC4 butanol. So butanol is written as C4H9O, okay, OH. Then plus ethanoic acid is written as C3, okay, COOH. Then now what is going to form? What is going to form is C4H9COOCH3 plus water. So when an acid reacts with, this is liquid, this is aqueous, this is aqueous, and of course this is what? Aqueous. Okay? So when an alcohol reacts with an acid, what is formed here is an ester plus water only. These are the products that are formed. So this is the butanol, and this is what? Ethanol. Okay? Ethanoic acid, acid. So now what is formed is the product called, what do you call the product? Butanol, butyl ethanoate. So butyl ethanoate is the product formed. This is the product. We are going to look at esters at some point as we go on in the question. But at the moment, this is what we can write. Now, is the equation balanced? So here, there's a condition that we can put that concentrated. The condition is concentrated sulfuric acid. That is the condition. Okay? So this is the reaction that occurs. So if you are given the question to write the reaction, right here is the reaction. The colorless liquid produced here is butanol, and now the equation when the colorless product or the product that is produced above react with ethanoic acid, it produces butyl ethanoate, that is an ester and water only, and this is the reaction. So counter check if all the atoms are balanced. Otherwise, this is how we write it. Up to question 7, let us look at question 7. So like I said, these questions are not arranged necessarily in the years they were examined, but in order of the topic. So we are advancing. So propene, which is this one given, react with steam to give a major product which is proper 2O. State the essential condition necessary for this reaction. So in short, what are the reactions that are essential or important for this reaction to occur? Now, what is the reaction that is occurring here? To start with, you need to understand the reaction. Now, propene react with steam, which is water, to give a major product, propan 2O. Okay, so this is called hydration reaction. Hydration reaction. So alkenes in general, they undergo hydration reaction to produce what? Alcohol. Okay, to produce alcohol. Now, what are the conditions, or what is the condition? What are the conditions necessary here? So the conditions are essential for this reaction to occur. One, you need a catalyst. Okay, a catalyst. And what is the catalyst in this case? Phosphoric acid. So for hydration to occur, there should be a catalyst, which is phosphoric acid. Then there should be a temperature. Okay, another condition is temperature of about 300 degrees Celsius. Then what is the other one? Pressure. So there should be also pressure of about 60 atm, that is 60 atmosphere. So these are the conditions for hydration to occur. So at any point we are going to come across the question for on hydration. Ask the condition, you should be able to remember this, please. Okay, so that is this answers question A. Now, it doesn't necessarily mean that you are asked to give all the three, but here says state the condition necessary, or state the essential conditions necessary for this reaction. So yeah, you have to give this, and I don't think you can forget this. Then of course B, we are saying state the kind of reaction that occur between propene and the steam. So this one I just explained earlier, and that is what? Hydration reaction. Okay. Then now, however, there is also a minor byproduct formed in such a reaction. So now listen, when propene is like this, okay? So when propene reacts with water, two of the products are formed. One is called the major product, the other one is called the what? The minor product. So let me put here HO, okay? HO. Reacting. So what is going to happen is that one is the major product, one is the minor product. So you can check on what we call Markovnikov rule, that what happens. So now, when is the major product formed? So look at this. This middle carbon here, likely OH will attach to this part. Okay, it has high affinity for OH, which means when OH attach here, what is going to form in terms of alcohol is going to be like this. Okay, OH will be here. Let me just draw it down here. OH will be here. Okay, OH will be here, and of course here we are going to find hydrogen. Here is carbon. Here is hydrogen, hydrogen, hydrogen. Okay, then here we have carbon. Then now, hydrogen is likely to attach to a carbon that is attached to many hydrogen. That is where the double bond is. Hydrogen is likely to attach to a carbon that has a lot of hydrogen. Look at this, it has two hydrogens. This one has only one hydrogen. So hydrogen is likely to attach to a carbon that has what? A lot of hydrogens. And therefore hydrogen is going to attach here. Now, this is what we call secondary alcohol. So please, I'm not going to go into detail because this one might be beyond your scope. But when you enter into A level and all that, that is well explained. So what I'm trying to say is that likely OH will attach here, and what kind of alcohol is going to form is called propan-2O, because the OH group is at carbon 2. If we were to count 1, 2, 3, so it's at carbon 2. So this is the major product. But another possibility is that hydrogen can attach here, and of course OH attaches there, and this one forms what? Propan-1O, because the OH is at carbon 1. So this is only in relation to the double bond, where the carbons that attach to the double bond. So this one is the minor product. Okay, so when they tell you that, however, there is a minor product formed in such a reaction, give the full displayed structure formula and systematic name of the byproduct. Okay, so what we are told is the byproduct, the minor byproduct. What is the displayed structure? So the displayed structure, it is this, where the carbon is at 1. Okay, I mean where the OH is at carbon 1. So this is the displayed what? Structure. Now what is the systematic name? Is propan-1O. That is the systematic name. So that is how you need to look at this. So what I've explained is that, how do you know that the major product or the minor product? The OH, like I said, it will attach likely, if you have double bonds, it will attach likely to the carbon that has less number of hydrogens. Okay? Here there was like this. So this one has only attached to one hydrogen. So which means when the double bond break, it will attach here and not here. But there's a possibility that it might attach here, which forms the what? The minor product. So the major product is called the primary alcohol, the secondary alcohol. Then the minor is called the primary alcohol. I guess you get that point. Okay, so that is basically what really happened. So get to check on Markovnikov rule and what it says there. Okay. Then give, okay, this one just answered. Let us see if we can look at the other one. How is the major product separated from the minor product? So the major product is separated from the minor product through the process of distillation. These, they have different boiling points, so they boil at different temperature, and therefore they can easily be separated because they tend to have different boiling points. Okay, so can be removed by the process of distillation. Okay, fractional distillation. So that is basically how it can be removed. Then now the second one, so by fractional distillation. So please get to check on this also, okay, how everything is done. Otherwise I might explain something that is beyond. Okay, so if 2.1 kg of propene is fully reacted with steam, if 2.1 kilo, that is kilogram of propane is fully reacted with steam, calculate the mass of propane 2O that would be formed. So this one, how is the mass, what is the mass that is going to be formed? Okay, so if you look at the reaction that is there between propene and propanol 2, it is like this. Okay, so the formula is going to be, or reaction is going to be like this. Propene written as this. Okay, so propene as C3 6 reacting with steam. What is going to be produced, or what is going to produce, is propanol. Okay, written as C3H7OH. Okay, you might be wondering where this O is coming from. The general formula for alcohol is this one. So if we are looking at the alcohol that has 3 carbons, because here 3 carbons here, as you can see, so we just put a 3 here, so it will be C3, then 2 multiplied by 3 is 6 plus 1, 7 here, and OH. Okay, so that is the reaction. Now you check the reaction if it's balanced before we even start calculating. So we have 3 carbons here, 3 carbons, we have 6 hydrogens plus here 8, we have 7 plus 1, 8, oxygen 1. So the equation is balanced. Now we can start solving. So we're saying 2 kg of propene, so 2.1 kg of propene was reacted fully, and of course to form propanol. So what is the mass of propanol that was formed? So here the mass we don't know. Okay, so we are going to use mass to mass. That is the fastest one that we can use, but we can also use where we find the number of moles of this one. Then we use mole to mole ratio, of which we can find the moles of this one. Then we use number of moles is equals to mass over molar mass. But of course we can just go direct. So how does mass to mass work? So find the relative molecular mass of this one and we treat it as mass. And of course the relative molecular mass of this one, it is going to be, how many carbons are they? 3 multiplied by each carbon has a 12 mass. Then hydrogen 1 multiplied by 6. If you add, this is 36 plus a 6 is going to give us a 2, 1, so a 42. So this first part is giving us 42. Okay, so 42 kg, it is going to be 42 kg of ethene react to form 42 kg of ethene react to form what of the molar mass of this one? Carbon 3. So carbon 3 is 3 multiplied by 12, which give us 36. Then plus hydrogen, there are 8 of them. So each carbon has 1. So 8 times 1, 8. So 36 plus 8. Then oxygen is just 1 multiply 16. If you are to add this, we have 36 plus 8 plus 16. Okay, what is the answer for these two? 8 plus
6 is 14 plus 6 is 20, so 0 remainder 2. This plus is 4 plus 2 is 6, so 60. So this one produces 60 kg. So 42 kg of ethene react with steam to form 60 kg of what? Propanol. Then what about 2.1 kg of ethene? What would be the mass here? So you cross multiply here, and when you cross multiply, it's simply going to be 60 multiply 2.1. So 60 multiply 2.1, and this one is giving me 126. So this one is going to be 42 kg x equal to 126 kg. Remember, this one has kg and also this one has kg. So kg. Then divide 42 kg. What we want is x, 42 kg. Okay, so what are we going to have as our x? Let me just take it there. So x is going to be 126 divide 42. So divide 42, we are going to have 3 kg. So 3 kg will be needed, or 3 kg will be produced if 2.1 kg of ethene was reacted. So the answer that we can find is what? Or the answer is 3 kg. So that is how we simply work out this one. Okay, now let us answer question 8. So question 8 is coming from 2021 GCE, and the question reads, structure displayed below is the polymer that was formed from monomer Y. Name the monomer Y. Now, when you are naming, as you name the monomers, you can easily trace them like this. So I said the double bond normally, no matter how long the compound, always write it in the form where you find that the double bond, where the double bond is, whatever chain that is, whatever number of carbons that are extending, you write them as groups, as groups, that is up and down. So which means you're only dealing with the 2 carbons. So check the 2 carbons if there's something repeating. So what I'm saying is that cut the polymer into 2 carbon and see the repeating unit. Look at this. So in the first one, these 2 carbons, because this is where the double bond was. Okay, so you have how many carbons? 1, 2, 3, 4. What about this? 1, 2, 3, 3, 4. So you've seen the repeating carbons, huh? So when you cut it into 2 of the carbon in the long chain, that is the horizontal chain, you are going to discover from which monomer it is coming from. Okay? So look at this. 4 carbon, what monomer is that? That is called butene. Okay? Butene is the monomer from which these were formed. Now, if we were to write the systematic name of the butene that was involved, you find that it will be that is but-2-ene. Okay? 2-ene, because it was like this. It was like this. Carbon, then carbon here, carbon here. That is the reason why you are finding carbon here, hydrogen there, hydrogen. This is carbon, this is carbon, this is it, or there's nothing here. So this is the reason why you're finding them like this, because this whole was written down here, and this whole, this was written down here. Okay? So that is how it is. So please, the name of the monomer is called but-1-ene or butene. Okay? So but-2-ene, not but-1-ene, please. but-2-ene. That is the monomer or butene. So to be on the safe side, because what kind of butene was it? Okay. So B, name the monomer Y. Okay, what was the first one? Name the polymer Y, or name the polymer. So the polymer, please, is called polybutene. We've answered the question that we're not supposed to. So this one is called polybutene. So which means a lot of butenes are joining. Then what is the name of the monomer? Monomer is the smallest unit. It's called the butene, of which I said is but-2-ene, because the double bond was as carbon 2. Construct the displayed structure of monomer Y. So monomer Y, that is when now you are going to know the importance of writing it like this, because you are going to know where the double bond is going to be. So in this case, it will be at carbon number 2. How do I know that it was at carbon number 2? Look at this. Whatever is breaking here, this was the double bond. So even here, this was the what? The double bond. Now look at this. We have 1, 2, 3, 4. So the double bond was carbon 2. The double bond is at carbon 2. So that is how you look at it. Okay? So how do you draw it? It will be like this. Carbon, carbon, carbon. So let me just put it here. Carbon, carbon, carbon. So 4 carbons. Between there was a double bond. Then here it was like that. Here like that. Hydrogen, hydrogen, hydrogen. This one needs a hydrogen there. This one needs a hydrogen there. Hydrogen, hydrogen, hydrogen. So this is the displayed structure of monomer Y. This one. Monomer Y was reacted with steam under the suitable conditions, and organic compound Z was produced. So like I said, we've started now looking at just a repetition of what we've looked at. So monomer Y was reacted with steam. So immediate to hear of steam and propene, immediate to hear of steam and alkenes, just think of what is formed is the alcohol. So in this case, we said the monomer is butene, or but-2-ene, which means the product will be what? Butanol, alcohol. Now, is it a question that we've been asked? No. The question is that to which homologous series does it belong? Compound Z. Compound Z is the one that is formed after hydration or adding of steam. So it belongs to what? Alkanos or alcohols. Okay? Alkanos or alcohols. That is where compound Z belong, because it was formed after hydration reaction, that is the formation of alcohol. Write the general formula of the series stated in C. Okay, so what is the series stated in C? We've just talked of alcohol. So the general formula of alcohol in short is CnH2n plus 1 with the OH as the functional group. This one is the general formula, okay, of alcohol, to which all alcohol conform. So that is something that you should know. Okay, so up to the 9th question. Ethene, which is this one, is unsaturated hydrocarbon, and it is manufactured from petroleum as shown below in the diagram. So the whole process of this, we are looking at the manufacture of what? Ethene from petroleum. Okay, now what are the questions? So as you can see, petroleum, it contains about several components, hundreds of them. So through process X, it results into what? Kerosene. Now kerosene through process Y results into what? Ethene. Ethene through process Z results into what? Polyethylene. So what is prepared here? We are looking at ethene. Okay. Now what are the questions that follows? Name the process Y and Z. Name the process Y and Z. So for the sake of our learning, we are going to name process X, we are going to name process Y, and we are going to name process Z. Now, the process by which petroleum is converted to kerosene. So kerosene is one of the products of petroleum that is produced, and this process is called fractional distillation. So fractional distillation of petroleum or crude oil, that is what we call this. Okay, because these components that are found in this petroleum have different boiling points, and of course they have different boiling points, so that makes them possible to be separated by this process. Then what about Y? What is process Y? So the process by which kerosene is converted to ethene. Now ethene, we can say these are small organic compounds. These are small compounds. Now from larger one, which is kerosene, what process is that? you understand, or you should know that that is what? That is the cracking. Okay? Then now, from this one now, ethene, process Z now to polyethene. So here there's a term poly to guide us. So you know that that is polymerization. Now what kind of polymerization? That is called additional polymerization. Okay? Additional polymerization. Alkenes or ethene are converted to polyethene by the process of addition polymerization. Okay, so that is the process Z. Now, let us answer the questions now. Name the process Y and Z. So we've already named them. Y is the cracking, Z is additional polymerization. Describe either process Y or, describe either process X or Y. Include necessary conditions for a reaction. So here they've given us option. We can choose to describe process what? Process Y or process X or Y. And of course include necessary condition. Okay? So now, which one are we going to look at? So we are going to look at both. So Y we said is cracking, and where we are coming from, you know that cracking is just a process of breaking down large, heavier and complex molecules into smaller ones. So here we are going to describe, let us describe process Y first. Okay, Y, so which is cracking, since they are saying X and Y. So to start with, let us describe process Y, which is cracking. Okay, now cracking is just a breaking down of large and heavier complex molecules into smaller ones. Okay, what are the conditions? What are the conditions? So the conditions for cracking is that there should be a catalyst. So a catalyst. Now what is a catalyst that is used in this case? Aluminium oxide. Okay, aluminium oxide is used as a catalyst during the process of what? Cracking, or silicon oxide. Silicon oxide, which means this is catalytic what? Cracking. Okay, and of course I'll put heat, okay, for thermal cracking. So the condition for catalyst aluminium oxide or silicon oxide, but for thermal cracking is heat. So these are the conditions. Okay, then what about the other one that we can describe? The other one that we can describe, or X. What is X? So X, since we are saying X is fractional distillation, okay, so X is fractional distillation. Now, how about fractional distillation? So, for fractional distillation, it involves the use of different boiling point. So, the condition is temperature. Okay, temperature, that is the condition. Then for Z, polymerization, and of course the condition is temperature of 200 degree, and of course pressure of 200 atp. So, those, at least I've described all the three. Okay, so the other question here, that is question C. Ethene can undergo hydrogenation process with hydrogen. Write the reaction equation using displayed structure. So we are writing the displayed structure of the hydrogenation of ethene. So we are going to start with, that is ethene, writing it like this. It's presented like this. Okay, and bear in mind this is the smallest alkene. Okay, so we are adding hydrogen, you represent it like this. Then what is going to form, you know that an alkane is going to form, okay, and that is ethane. So this double bond break, and of course room for attachment of two hydrogens, and therefore this one is going to become like this. Okay, hydrogen attaches hydrogen, and of course we are going to have what we call ethane. Okay, so hydrogenation conveyed hydrogenation conveyed alkenes into alkanes. So in this case, ethene into ethane. That is what forms. Okay, and that is the hydrogen. Now, what are the conditions? The condition UV light is one of the conditions. So UV light or high temperature. Okay, so if you are asked of the condition, UV light or high temperature is involved. And of course, the importance of this process, I think we've looked at the question at some point. But if you've forgotten, the importance of the process of this process, that is hydrogenation, it is used in industry to convert, that is vegetable oil, or to hardening of vegetable oil. Okay, so here for question 10, let us look at question 10. So the structure below is for a polymer. So this is question 10 is coming, or this question 10 is coming from 2017 GCE. So the structure below is for a polymer. Name the polymer. So equally here we are naming the what? The polymer. So now for us to name the polymer, we need to know the monomer. So now look at this. I said you divide it into two carbon, 2 carbon. So we are going to cut it 2 carbon, 2 carbon. And now establish what is the basic unit. What is the unit here? The smallest unit. You find that this one has how many carbon? 1, 2, 3. Okay, so this is 2. This is 3. What about this one? 1, 2, 3. 1, 2, 3. So this is the basic unit. So the basic unit has 3 hydrogen, and that is called what? Propene. So alkene, please, are the only ones that undergo polymerization. That is additional polymerization. Additional polymerization. Take note of that. So alkenes. So what is the name of this alkene? It's called propene. Okay, because it has 3 carbon. So that is how you determine the monomer. So now what is the polymer now? The polymer therefore is called polypropene. Okay, so the polymer is the polypropene. So polypropene is the polymer. Okay. Then now, name and draw the structure formula of the monomer for the polymer. Name and draw the structure formula of the monomer for the polymer. Okay, so what is the name? So the name for the monomer is called propene. Okay, propene. Then if we are to draw the structure, it's going to be like this. Okay, so like this. Then the double bond here, since this one is this side, so the double bond was here, so it will be like this. Okay, it will be like this. So this is the structure, and of course the monomer is the propene. Okay, you need to check hydrogen attached to 4, carbon to 4, carbon attached to 4, carbon attached to 4. So that is how you check it. Okay, then state the type of polymer that is shown above. So this is called additional polymer. Okay, so it's an additional polymer. Okay, because it is formed from what? Additional polymerization. Okay, so it's an additional polymer. Then give one use of the polymer. What is the use of this polymer, which is polypropene? So it is used in making what? Used in making plastics. So it is used in making plastics, used in making insulators, used in making insulators. And what is the reason why it is used in making insulators? It is hard. Then used in making what? Plastic packaging. Okay, so these are some of the uses of the polymer. You can look at some more. So these are some of the uses. Then question C, ethanol is an alcoholic beverage which can be brewed from cassava. Ethanol is an alcoholic beverage which can be brewed from cassava. Outline the process by which ethanol can be brewed. So this question, just for your own information, it had 5 marks. Okay, so how do you explain the process of beer brewing from cassava? So this is how you write it. So I'll just read, I'll just dictate it. Okay, so cassava is pressure crushed, or is crushed. So the first part is that cassava is crushed and pressure cooked to release starch, which is glucose. I guess you've gotten that first line. So cassava is crushed and pressure cooked to release starch, okay, which is glucose, then mixed with water and yeast, then allow it to react for few days in the absence of oxygen at the temperature of 37 degrees Celsius. Then the enzyme in the yeast, which is called zymase, will help to convert starch into ethanol, and carbon dioxide gas will be produced. So that is the whole process of how ethanol is brewed. So let me just go through that once again. So cassava is crushed and pressure cooked to release starch, which is glucose, then mixed with what? Water and yeast, then allow it to react for a few days in the absence of oxygen, at a temperature of 37 degrees Celsius. The enzyme in yeast, zymase, will help to convert the starch to ethanol, and carbon dioxide gas will be produced. So here what I can outline are the conditions necessary. So the condition necessary is the lack of oxygen or absence of oxygen. Let me just write, not lack, let me write absence of oxygen is one of the conditions for this process to occur. Temperature of 37 degrees Celsius. Then of course enzyme, okay, enzyme is needed in this reaction. What is the enzyme used? Zymase, okay, that is the enzyme that is used. So these are the conditions for the process to occur. Then ethanol is used as fuel. Construct a balanced chemical equation for its complete combustion. So we are looking at complete combustion of ethanol now. How is it, or how is the equation? So ethanol is written as CH 5OH plus what? 3 oxygen. Okay. This one results into 2 carbon dioxide. Is complete combustion, please. So carbon dioxide and water is produced. So this is the balanced equation if we were to put a 3 here. So that is the balanced equation. This is the gas. This is a liquid. Okay. So that is how you write the balanced equation. Okay. Okay, so let us look at question 11 now. So question 11 is coming from 2022 school certificate. So the question reads, the diagram below shows some of the reactions of ethanol. The diagram below shows some of the reactions of ethanol. So surely you know that what is reacting here is the ethanol. So what are some of the reactions? So this is the reaction scheme. Okay, so as you can see, ethanol is here. It undergoes this reaction, produces ethene. It undergoes this reaction to produce gas R, and of course water. Undergo this reaction and produces solution P. So the arrows where they are going, that is the resulting product, and of course what is in the middle here is showing the process. So here ethanol, which is alcohol, undergo oxidation and produces solution P. And here you can read ethanol undergoes process Q to produce ethene. Here it undergoes combustion, complete combustion, produces gas R and of course water. So this is simple. Let us look at the questions. Name the structure formula of ethane. Okay, so the structure formula of ethane, if we are to draw it, it is like this. Okay, ethane is just two carbon. Since it has a single bond, so it appears like this. Okay, so this is the ethane. Okay, this is ethane. Then given the give the name 1 of solution what? P, gas R, and process Q. Okay, so we are going back. This is attached to the question or the diagram that you have just looked at. So the first question is that what is solution P? Now, what is solution P? So when alcohol undergo oxidation reaction, what is produced is the carboxylic acid. Carboxylic what? carboxylic acid. Now, what is the name of the carboxylic acid produced? So here is ethanol. So this one is going to be ethanoic acid. So solution P is ethanoic acid. So we can write here ethanoic acid. Then what is gas R? Gas R here, complete combustion of alcohol. We said what is produced. So in most cases, complete combustion in these organic compounds, you are going to find that carbon dioxide and water is produced. So gas R automatically is what? Carbon dioxide. So long as there is complete combustion, just know that what? Carbon dioxide, okay? Carbon dioxide is produced. Okay, so gas R is carbon dioxide. Let us look at the other question, process Q. Now, what is process Q? Process Q produces ethene. Now, the process of making alcohol, one of the processes is hydration, the addition of water. Now, when you remove water, let me start from here. This process of alcohol can be formed, in short, one, from fermentation and also hydration of ethene, alkenes. Hydration of alkenes, which means when you add water to alkenes, you result into alcohol. So now, an alkene here, that is given an example of an alkene, or the one that represents an alkene is ethene. So which means here, for you to come up with ethene, it's more like when you add water to this, going this one, you're going to form alcohol. But when you remove water, you're going to form this. So here the process, what I'm trying to say is that this process is called dehydration. Since the formation is called hydration. So dehydration. Okay? Write the balanced chemical equation for the complete combustion of ethanol. This one, I think we're just from writing this equation. So it is C2, that is ethanol. Okay? Plus what? 3 oxygen. Then what is formed? 2 carbon dioxide. So I'm just writing the balanced one. 3 water molecules. So this is the gas. This is the liquid, This is the gas. All these gases. And of course, that is what happened. Okay? So this is the balanced equation. Be able to check it and make sure that it's balanced. Otherwise, that is the equation that you write on this one. Okay? So please look at how simple it is. Look at how simple it is. So you should be able just to start the scheme. Okay? Just to start the scheme. And normally these schemes start from where they've told you. Here I say the following diagram shows the reaction of ethanol. So it means everything is centered upon ethanol. Okay? So what I'll emphasize is that on each compound that we've looked at, make sure that you know the reaction it undergoes and all the conditions of the reactions. Okay? So here you should know what are the conditions for this oxidation to occur. Okay? So oxidation can occur just on its own in the presence of oxygen, but also can be made to occur first by using a catalyst. Okay? Then also dehydration, look at the conditions that are involved. Okay? So if you do that, then you have no problem with the topic. Okay? Okay, so up to question 16, or question 12, So up to question 12, and this one came in 2016, school certificate. The question reads, the following sequence of reactions, that is glucose, ethanol. So here the reaction, the way you can look at it, is that glucose is converted to what? Ethanol. Then ethanol is converted to what? Ethene. Ethene is converted to what? Polyethylene. That is how you can look at it. So the first question is that, what name is given to the process by which glucose changes to ethanol? What name is given to the process by which glucose changes to ethanol? So this process is called fermentation. So alcohol can be formed, okay, let me not go into that. So this one is called fermentation. Then now, name the enzyme responsible for the change in above, that is one above. We're just from looking at the enzymes previously. So this one is called what? Zymase. So the enzyme is in the part that I was explaining how glucose is made from, how alcohol is made from cassava. So this is the zymase. So the enzyme is the zymase. Then what gas is produced during the process? So when glucose is converted into alcohol through the process of fermentation, the reaction produces carbon dioxide. So the gas, therefore, we can say is carbon dioxide is produced. Okay, so that is a gas. Name the process and the catalyst used when ethene changes into the polyethylene. So we are looking at this process. Okay, so the process is called additional polymerization. Okay, additional polymerization. We've looked at quite a number of these. Additional polymerization. Now, what are the conditions? The conditions, you need a catalyst. Okay, titanium compounds. Okay, so here you need a catalyst, and the catalyst is called, I don't know how you can pronounce this one as you, zygranato, nato or nata catalyst. Okay, so zygranata catalyst are just compound of titanium. So compounds of, or you can say titanium compounds. Okay, so this is a catalyst that is used in this process. Okay, compound of titanium such as titanium 2 chloride. So I say the catalyst is zygranata catalyst, of which they are compound of titanium. And now compound of titanium, we are looking at titanium 2 chloride, and of course compounds of aluminium. So basically that is what we can look at as a catalyst. Otherwise the reaction or the process is called additional polymerization. Then draw the structure of the polyethylene with 3 repeating units. So here we are told to draw 3 repeating units. So now here I'm going to put this. So polyethylene is formed from ethene. So ethene is drawn like this. Okay, up hydrogen, down hydrogen, up hydrogen, down hydrogen. So you need to present it in this manner and not where the hydrogens are extending this manner. Okay, so plus another ethene, so 3 of them. Okay, so we add 3 of them. So it's going to be like this. Another one we add, so like this. 3 of these. Okay, then now what is going to be the product? So the product here, there are how many? 1, 2, 3, 4, 5, 6. So 6 carbons. Okay, 6 carbons are going to be attached. How many are these? 4. So I'll put another one. Okay, here another one. So here outside there's this opening for more attachment. So you draw the you put the hydrogens like this. So this is hydrogen, 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 hydrogen. And of course this one like that, like that, like that. So this is the polyethylene. Okay, polyethylene. When the polyethylene is burned in excess air, in this case the air that, the part of air that supports burning, you know that is oxygen. So this one is just the same as when polyethylene is burned in excess oxygen, 2 products are formed. Name the products. So this is combustion reaction. Now when the organic compound undergo combustion reaction, what happens? Products are produced. It depends. So here I'm saying excess, so which means carbon dioxide. What else? Water are the 2 products. So carbon dioxide and water are the 2 products. Okay, so this one, please, is the answer to the first question, which is this part. Okay, to the first question of repeating units. Then E, polyethylene is non-biodegradable substance. Explain what it is meant by non-biodegradable. What does it mean, non-biodegradable? So for non-biodegradable, what it means is that it cannot be broken down by bacteria. You know, there are some of the things that decay when bacteria, or they can easily be broken down by bacteria, and of course decay process occur. But for these, they are non-biodegradable because they cannot be, so we can say cannot, because cannot be broken down by bacteria, because cannot be broken down by bacteria. Okay, so that is why it means non-biodegradable. Okay, now state the effect of such polymer on the environment. Now, if it cannot be broken down by bacteria, people will resort to what? Burning them. And of course, burning them will cause what? Pollution. Okay, so we can say causes air pollution. Causes air pollution when burned. Okay, so causes air pollution when burned. Aside from air pollution, they also called land pollution because they are difficult to what? To recycle. So they are found just on the land, and of course that is land pollution. So those are some of the effects that we can look at. Okay. Then up to question 13. Question 13 comes from 2019, that GCE. The series of the process below shows the link to the formation of ester or ester known as ethyl ethanoate. So ethyl ethanoate is the ester that is formed here, and now the process here you can see ethene through process K is converted to ethanol. Ethanol through process L is converted to P, and of course P through process M is converted to ethyl ethanoate. What is the question? From the reaction scheme above, name process C, K, L, and M. So what is process C? Let me just fill it here. What is process K? So the process by which ethene converts to ethanol, we've looked at that. We said this is what? Hydration. So process K is C, hydration. What about process L? Ethanol now converts to this part. Okay, so this part is the one that undergo process M to form ethyl ethanoate. Now, ethanol in this case converts to, so this one is supposed to be carboxylic acid, because carboxylic acid undergo process L to form ethyl ethanoate. So what is now this process L? So this process L, the process which converts ethanol to acid, or which converts alcohol to acid, is called oxidation. So this process is called what? Oxidation. Okay, now this carboxylic acid that is formed here, which is the ethanoic acid, undergo process undergo process M, which is the esterification. So process M is called ester. Esterification, and now it forms what? An ester, which is called ethyl ethanoate. So these are the process. So process K is hydration, oxidation, esterification. Now what is the other question? From the reaction scheme above, okay, name, we've done this. Construct the chemical equation describing the process K, include state symbols. So process K is right here. So they want us to construct the chemical equation for hydration. So now we have ethene. We have ethene. Yes. We have ethene. What process is this? Hydration, yeah? Okay. So addition of steam. You know that this is addition of what? Steam. So you have ethene, which is a gas, then react with steam, which is water in gas form. Okay, then what is produced here? What is produced is the alcohol, which is ethanol. Ethanol is the one that is produced. Okay, then what are the conditions? Phosphoric acid acts as a catalyst, then also the temperature of 300 degrees Celsius, and of course the pressure of 60 atm. So this is the reaction that will occur for this process. Okay, so this is the chemical equation that will occur. Is it balanced? If I were to check carbon 2, carbon 2. Hydrogen here, we have how many here? 6. We have how many here? 6. So oxygen here, 1. Oxygen here, 1. So the equation is the equation is balanced. Okay. So for question C saying, state the common name or state both the common, the chemical and the common name for substance. Okay, for a substance. Okay, now which substance? So you are looking at the common name. So here construct the chemical equation for process K and include. So here it has to be state both the chemical name and the common name for substance P. So he said the chemical name is called what? Ethanoic acid. Then now the common name is called acetic what? Acid. So this is something that you should know. Okay, so the common name for substance P, which is ethanoic acid, as you can see here, we said what to form is ethanoic acid. Okay, so the common name is acetic acid. State the general formula of the series where substance P belongs. So the general formula from which it belongs, it is CnH2n plus 1 with a functional group that is the COOH. Okay, so that is the general formula of carboxylic acids. Okay, so up to question 14, below are chemical formulae of organic compounds. So these are chemical formulae of organic compounds. As you can see, just identifying them, this one is an alkene, this one is an alcohol, this one is an acid, this one is an acid, this one is an alkane. So this is an alkane because double the number and 2. This one double the number, so this one is an alkene. So alkene. This one is an ethene in short. This one is the methanol. Okay, methanol. This one is how many are they? Okay, it's an acid. Let's just say because of this COOH. Okay, this one also COOH. Please, COOH can be written as C2H, which is just the same as COO. Double O, that is the H. Take note of that. Name the compound which react with what? Steam. So which compound react with steam? You know that the ones that react with steam are alkenes. Okay? So name the compound that react with steam. So the compound that react with steam here is C2H4. Okay? And that is what? Ethene. Okay? So alkenes are the ones that react with steam to form alcohol. And if I were to check, is it only this one? Yes, right here. Draw the structure formula of a compound which turns blue litmus paper red. Draw the structure formula of a compound that turns blue litmus paper red. So what are we going to do here? Because we've identified more than what? More than one acid. So I'm going to draw just for this, okay, because this is an acid, this is an acid. Okay, so it's going to be like this. If I were to draw it, okay, how many carbons does it have? So for this one also I can choose to draw this one or this one. Okay, let me just draw this one. So this one has how many carbons? 1, 2. This is from the functional group, so we don't count among the carbons. It's from the functional group. So it's going to be carbon 1, carbon 2, then attached to the functional group, which is drawn like this. Like this. Then here you can attach the hydrogens. Can attach the hydrogens like that. How many are they? Like this. Okay? So this one is called propanoic what? Acid. By the way, you need to know that the first acid has carbon number 0, which is this one, which is the methanoic acid. So if you are told that the acid has 2 carbons, just know that it's at position 3. The one that has 1 carbon is at position number 2. Okay? The one that has 0 is the one at position number 1. That you should know. Okay? So it's the one that turns blue litmus paper red. That is a characteristic of an acid. Okay? Do you have other questions? So choose 2 compounds which undergo esterification. Now esterification is between acid and alcohol. So in short, choose an acid and of course an alcohol. Okay? So from this list, which one is an alcohol? I can choose this and of course choose this as an acid. Okay? So it's going to be CH3OH and HCO2H. These two, they undergo esterification and of course to form an ester. Okay? But you should know that occur between an acid and of course an alcohol. That is very important. How do I know that this one is an alcohol? Because of the OH. That is the functional group of an alcohol. Okay? The OH. And how did I know that this one is an acid? Because of the functional group, that is COH. That is COOH, which is this part. Okay? And this one is this part. Okay, so these, they can react and of course form an ester. Okay. Then now up to question 15. Ethanol is a product of many fermentation reactions. The molecular formula of ethanol is this one. Okay. Draw the displayed molecular structure of ethanol. So what they want is to draw the structure of this one. So how many carbons are they? 2. But of course we have the functional group, which is the OH. So I'll put OH here. Then now, hydrogens around, 5 of them, hydrogens, and of course hydrogen. This is the displayed structure of this one. Now please, when showing it, make sure that you show the OH like this. Don't write it like this. Okay, you have to show the bond that is in between there. When ethanol is heated with potassium dichromate 6, it is converted to ethanoic acid. What type of reaction is this? When ethanol is heated with potassium dichromate 7 or 6, it is converted to ethanoic acid. What type of reaction is this? So no doubt, this is the oxidation reaction. So oxidation reaction, we said, it can occur in presence of oxygen. That is just when you leave alcohol in an open place, but that process is slow. So to speed it up, we add a catalyst, which is potassium dichromate 6, and of course this one speed up the process of oxidation reaction. So therefore the reaction is called oxidation reaction. Okay? Then now, what is the other question? Give 1 safety rules to observe when handling ethanoic acid in the laboratory. You know that these are acids. Okay? These are acids. So what is the safety rule that you consider? So you have to wear gloves when handling what? Ethanoic acid. So wear protective gloves, please. Okay? Protective gloves when handling ethanoic acid. So think of other safety rules that you can undertake. So as you go through this, as you study, make sure that you look for some more. What are other safety rules that you can take? Ethanoic acid react with ethanol in the presence of a catalyst to produce a new substance. Look at this. This time around is an acid that is reacting with what? Alcohol. So what is going to form here is an ester. So esterification is a process of by which an acid reacts with an alcohol to form an ester. In this case, an acid is ethanoic acid, and of course the alcohol is ethanol. Name the catalyst used in this reaction. So the catalyst used here is concentrated. Okay, concentrated sulfuric acid is used as a catalyst. So take note of that. Then now, name, okay, this one is just from answering. Give the name and deduce the formula of the substance. Now, here, let me just take time a bit to explain about esters. So for esters naming system, the first part of the name comes from the what? The alcohol. Then the second part comes from the what? Comes from the acid. Okay? Now listen very carefully. Alcohol become, they attain, let's say for example of ethanol, it becomes ethyl. Okay? So in short, it becomes alkyl. Okay? So it becomes ethyl. So that is the first part for alcohol is ethyl. If it was methanol, it was going to be methyl. If it was propanol, it was going to be propyl. Okay, the first part of the name. Then now this one attains 8. Oic is removed and of course 8 is added. So which means it becomes ethanol yet. Okay, ethanol. So if it was methanoic acid, it was going to be methanoate. You remove IC, you add E, you add ATE, that is 8. So this one is going to be methanoate. And therefore the name of this product that is produced here, it is going to be ethyl ethanoate. So take note of this. The first part comes from the alcohol, and of course it becomes an alkyl. Methyl becomes, methanol becomes methyl, ethanol becomes ethyl, propanol becomes propyl, butanol becomes butyl, pentanol becomes pentyl, hexanol becomes hexyl, and of course, and so on and so forth. But for acids, the oic is removed and you add 8, and that makes ethanoic acid becomes ethanoate, propanoic becomes propanoate, pentanoic becomes pentanoate, hexanoic becomes hexanoate. So something like that. Okay, so that's how you come up with a name. Now, how does the reaction occur? Here the name we've achieved is called ethyl ethanoate, but how does the reaction occur? So you're going to have ethanol like this. So you show OH like this. Then now here you have the hydrogens. So you're going to show it in terms of structure this. Okay. Then reacting with what? An acid. Okay. I will draw the functional group this side, orient it like this. So this is called ethanoic acid. You remember what I said? The second acid has one carbon. The first one has 0. So ethanoic acid, it has 1 carbon without counting this carbon, because this carbon is from the functional group. So we leave it out and just count this one as the 1 carbon. Okay, so this is how it is. Now what is going to happen here? What is formed, you know, that is an ester and water at the end. So what happened here, you need to pay particular attention. For the ester to form, the alcohol contribute a hydrogen. This one contribute what? Contribute the OH. Okay, and therefore these are going to join. Okay, this is the ethanol. This is ethanol, and this is what? Ethanoic what? Acid. So you draw them in this orientation. They are going to join. So this oxygen is going to bond to this carbon here. So it is going to be like this. Let me just draw it, just the carbon chain. So 2 carbons, and of course OH. Let me put, it is going to bond to this one. So it's going to be like this. Okay, and of course 1 carbon there. So like this. Then here you can put the hydrogens. Also here you can add the hydrogens. Here the hydrogens. Here the hydrogens. Okay, so that is what is going to form. Okay, and this is called the ester linkage, or this is called the ester linkage. So this is how the product is going to form. Okay, so this is called ethyl ethanoate. Okay, so we've just answered that part. So which part is remaining? So the other question is that is question D. Ethanoic acid is weak acid, or is the weak acid. It can react with metal metals such as sodium and magnesium. Let me just read that. Ethanoic acid is a weak acid. It can react with a metal such as sodium and magnesium to liberate hydrogen, which means to produce hydrogen. And that is what happened for a typical, for acids. Generally, they react with what? They react with metals to form hydrogen gas. So here they are telling you that can react with a metal to form hydrogen gas. That is in the case of magnesium and sodium. Okay? Then compare the rate of reaction of ethanoic acid with sodium and magnesium. Compare the reaction of these two. Okay? So, the rate of reaction here, I'll just dictate. The rate of reaction will be faster in sodium compared to what? Magnesium. And what is the reason behind that? If you look at the reactivity series, sodium is on top in terms of the series. It's most reactive compared to magnesium. And therefore, it reacts faster compared to what? Magnesium. Okay? So, one reason is due to their positioning on the reactivity series. So, that is what you can explain. Okay? So, the rate of reaction will be faster in sodium compared to magnesium. In the reactivity, compared to magnesium. This is because in terms of their reactivity, sodium is more reactive compared to magnesium. Okay? It's up there in the reactivity series. I guess you get the point here. Alright. Then, what is the other question? What would be observed when aluminium is added to ethanoic acid? Give a reason for this observation. Okay? So, when aluminium is added now to sulfuric acid, the reaction will not react. Okay? Because in this case, aluminium, although being a metal, it reacts with oxygen, and of course, it's rarely found in free state. It reacts with oxygen and form what? Aluminium what? Oxide. This aluminium oxide form a coat on top of aluminium. So this coat protects the metal from what? Reacting. So when you react, when you put aluminium in the in acid, you find that this protective layer outside, which is aluminium oxide, it will protect it from what? From reacting, and hence no reaction will occur. Now, what is the application to this? Give one use of aluminium based on that one. It is used in making of what? Cooking utensils, such as pans. Okay? So, because of that non-reactivity of aluminium, it is used in making of what? Making of cooking utensils, such as pans and all that. Okay? So, that is what you need to know on that one. Okay? Up to question 16, the list below shows the four members of the particular homologous series. As you can see, what is common in all these members is the OH, and therefore you can say these are alcohol. Name the homologous series to which the hydrocarbons or the compounds belong. So these, they belong to what? Alcohols or alkanos. That is where they belong, just by looking at their functional group. Describe the general molecular formula of the homologous series. General molecular formula is CnH2n plus 1 OH. You've seen. The questions are just coming as a repetition of what we've already looked at. State the relative molecular mass of butanol. So how is butanol written? Butanol is C4H. That is H9OH. This is butanol. Now they are saying relative molecular mass. So here you just have to add the mass of each atoms that is involved. So carbon, there are how many? 4. So 4 times 12. Then hydrogens, 1 times Z. Mass of hydrogen is 1. Then there are 9. There 4. Mass of carbon is 12. Then hydrogen, they are 10. Okay, so hydrogen 10. Then oxygen, you know that is 1, but times Z, 16. If we are to sum up all these, you are going to find, I guess you are going to find this one is 48, then this one is 10, then plus O plus oxygen, yeah, plus oxygen, what are we going to have? So plus oxygen, say, state the relative molecular mass of butane. Okay, so plus oxygen, you're going to have 16. So this is the 58. 58 plus 16, what is this going to be? This is 4, this is 1, this is 6. I guess it's giving you 64. Okay, so be able to confirm this. But for me, I found 64. Relative molecular mass, I've just found 64. Okay, so I found 64. Okay, 64. So kindly confirm what you found yourself. If it's 54 or what have you found? Okay, ethanol can be manufactured from either ethene or glucose. We've looked at how it is manufactured from ethene, that is hydration, and of course from glucose, that is fermentation. Construct the equation for the production of ethanol from ethene using structural formula, so using structures. So now you are going to say ethene drawn like this. They are saying using structures. So structures, if you hear of structures, just know that putting or showing bonds, then reacting with steam. Now water, we are going to present it like this. Okay, this is OH like this. Then now what is going to form? This OH, this one will break, and of course is going to form ethanol. Let me put OH here, okay, with a bond layer. So we have this. This is one that is going to form, and this is called ethanol. Okay, this is the water or steam. This is what? Ethene. Okay, so using structures. So this is how it is going to be. Okay, that is how it is going to be. Then now state the condition for the reaction in B above. What are the conditions? So the conditions here, 1, you need phosphoric acid as the catalyst. So a catalyst of phosphoric acid. 2, temperature of 300 degrees Celsius. So just a repetition of what we've looked at. Pressure of 60 atm. Okay, 60 atmosphere. The fermentation of glucose can be represented by the following equation. Okay, so the equation that this fermentation reaction is this one. So glucose, when it ferments or it undergoes fermentation reaction, what is produced here is 2 ethanol or 2 alcohol molecule, then plus what? Plus water. So this is the reaction here. Oh, I mean plus carbon dioxide. Okay, so sorry for that. 2 carbon dioxide. That is what is produced. Then now let us see the questions that follows. So as you can see from here, I guess this is the balanced equation if we were to check. 4 carbon plus these 2 carbon, 6. Here we have 6 carbon. Hydrogen, we have 12. Hydrogen, we have 6 here. Okay. Hydrogen, we have what? 12. Then hydrogens, okay, we have 6 here, but we have a 2 here, 12. Okay. So I guess the equation is balanced. Then now the question here, calculate the mass of ethanol that can be made from 70 tons of glucose. Calculate the mass of ethanol that can be made from 70 tons of glucose. So how do we do it? How do we deal with this one? The previous question we used mass to mass, so equally this one we can use mass to mass. How do we look at this question? So we are going to form a ratio. Let me just rewrite that equation here, which is glucose 6H12O6. Okay, this one result into 2 ethanol molecules plus what? Plus carbon dioxide. So here you are saying 70 tons of glucose. So 70 tons of glucose. What is the mass here? We don't know. So we just know that we want to find the mass of ethanol that will be produced when 70 tons reacted. So what are we going to do? In this case, we are going to find the relative molecular mass of glucose and treat it as what? Mass. Okay? Then that mass is going to relate now to what will be produced in terms of what? Ethanol. Okay, this is what I'm trying to say. So what is the molar mass of glucose? Here, quick one. There are how many carbon? There are 6 of them multiplied by each carbon has 12 mass. This one gives us what is the answer when we multiply 6 times 12. So 6 times 12 is giving me 72. So this one is giving me 72. Then plus hydrogen, which is 12. Hydrogen has 1 each. Then oxygen, which is 6 times each one is 16. Okay, so 96. So now we can add 96 plus 12 plus 72. Okay, so this one is giving me 180. So 180, we are going to put the mass tons of glucose produces what will be the molar mass of this one. Remember to multiply a 2 afterward. So carbon, how many are they? 2 multiply 2, so there are 4 carbons. So carbons 4 multiplied by 12 gives me 48. Then plus hydrogens, there are 5 of them, 6 of them, but multiply 2, so it gives me 12. Plus oxygen, just 1, multiply 2, so plus 32. Okay, 32. So this one is giving me 92 tons. So this one means that when 180 tons of glucose react with, undergo fermentation, produces 96 tons of glucose. What about 72 tons of glucose? How much of this will be produced? So when you cross multiply, it's simply going to be 180 tons x equal to 72 multiply 92, be able to confirm, is giving me 6,900, okay, 6,912 tons, okay, tons, okay, and tons, since we have 2 tons from this one and this one, okay, so again, multiply tons here. Then now divide 180 tons, divide 180 tons, so that we can have our x. So now our x here is equals to, so you see 6,912 divide 180 tons, and this one is giving me 38.4 tons. So this is the mass that will be produced when 72 grams of glucose was fermented. Okay, so 180 grams of glucose reacted to form 92 tons. What about 72? So 72 is going to give us 38.4. So how do you go about this one? So you just convert this one into, you find the relative molecular mass of this one and you treat it as mass. Get the mass of the units that you are given. So you are given tons. So you are going to put 180 tons. This 180 is just a molecular mass of this one. Okay, then here we are going to find the relative molecular mass of this one, but there are 2, so multiply 2, which is 92. Then here 72, what would be the mass here? So that is what we found. So that is the answer. State the use of ethanol other than alcoholic beverages. What is the other use of ethanol other than alcoholic beverages? So in other countries, ethanol is used as what? Is used as the source of energy. Is used in a source of energy. Okay, so that is one of the use of that is ethanol. Okay, then what is the other one? What is the other use of ethanol aside from the one that I've just given? So it is used as a disinfectant. You saw what happened worldwide due to corona. We have these disinfectant called hand sanitizers. So those are made from alcohol. Okay, so used as disinfectant. Here we can put hand sanitizer. Okay, then what is the other one? Used as fuel for heating and lighting. Like I said, used as a fuel, used as solvent for fats and other sources such as dyes and paint. So all those are the uses. Then ethanol can be oxidized to form ethanoic acid. Draw the structure of ethanoic acid showing all the bonds. So ethanoic acid, if we were to look at it, is the first one is methanoic, which has 0 carbon. The second one is ethanoic, which has 1 carbon. So it has 1 carbon and of course the functional group. So it's written like this in terms of molecular formula. Okay, like this. Okay, the general molecular formula of carboxylic acid is CnH2n plus 1 COOH. So this is the functional group. Okay, so 1 carbon, if you are to put here, you are going to come up with this. Now I want to draw the structure, so we are going to write the carbon and of course the other carbon, which is the functional group. Okay, to it there's oxygen and of course the OH. Okay, so like this, something like this. Then here you have the hydrogen. So this is the displayed structure of ethanoic acid. Name the organic compound formed when ethanol react with ethanoic acid. Name the organic compound formed when ethanol react with ethanoic acid. This is the situation that we had previously. So what is formed is called ethyl ethanoate. So ethyl ethanoate. Remember what I said? I said this is what we call esterification. So in esterification you have esterification. So you have an alcohol reacting with what? An acid. Now, the first part comes from the alcohol, of which I said it becomes an alkyl. Okay? Then this one attains H, which becomes ethanoate. So the name is ethyl ethanoate. Okay? Draw the structure of the compound you have named. So how do you draw the structure of the compound I've named? So for you to draw the structure, look at what happened in terms of reaction. So you have ethanoic acid like this, then reacting with ethanol. That is ethanoic acid reacting with ethanol. So ethanol is HO, then like this. Okay. Okay, so when they react here, what will happen? This contribute H, and of course this contribute OH. So it is now this that attaches. So the structure is C. Then we come to this. Then now this, which is O here. And of course this, like this, then this one is Z. Okay, so something like this. This is ethanoic acid reacting with what? Ethanol. Ethanol is supposed to have another carbon here, because ethanol is written as 2H5 like this. So it's supposed to have another carbon here, please, like this. Okay, like this. So this is the structure here, supposed to be another carbon here. So the structure is going to appear like this. Okay, and the molecular formula of this structure can be this HC3, or rather CH3, then COO, C2H5, something like this. Okay. All right. State the two conditions necessary for the reaction to take place? What are the two necessary conditions for the reaction above to take place? Okay? What are the conditions for esterification to take place? So let me just screen this one. So the condition needed, we need heat and of course concentrated sulfuric acid. So heat and concentrated sulfuric acid are the conditions necessary. So write this one as sulfuric acid. Okay? Alright, so question 17. Question 17 coming from 2017, that is school certificate, and reads, on the packet of a particular OPEC beer written 5% of alcohol per unit volume. Name the alcohol found in OPEC beer. Name the alcohol found in OPEC beer. So the alcohol found in OPEC beer is called ethanol. So ethanol is the alcohol found in OPEC beer. Okay, so describe how this alcohol you have named in A above is commercially produced from starch. So how is the beer that we've named produced from starch? So here we described the process of how alcohol is prepared previously, but we can just go through. So we can say cassava is crushed and pressure cooked to release glucose. Okay, then it is mixed with water, and yeast. Okay, then allowed to react for few days. In the absence of oxygen. Remember, in the previous one I just dictated how this is done, but here I'm writing in the absence of what? Oxygen at the temperature of 37 degrees Celsius. Now, in the yeast you find the enzyme. So the enzyme in yeast, what is the name of the enzyme? Zymase. Okay, zymase act on glucose. So zymase act on glucose and convert it to ethanol. Okay, so zymase act on glucose and convert it to ethanol and carbon dioxide. Okay, carbon dioxide. Convert to carbon dioxide gas. Okay, so the whole process produces carbon dioxide and ethanol as a product. So that is how it is done. Okay, so write down the balance equation for the formation of alcohol, and we are saying state symbols are not required. So we have glucose, which is C6H12O6, in this case yeast, and zymase, which is the enzyme, and of course you can put temperature of 37 degrees Celsius are the conditions. Then what is produced? Two ethanol molecules
plus 2 carbon dioxide. So I've just written the balanced one. So no state symbols are required. So that is what you need to do. Okay, give one use of alcohol. So before we even read the second part, so used as disinfectant. Okay, hand sanitizer or used as sanitizer. So it is used as disinfectant. Then now there are quite a number of uses, please, so you can go on and give some use that you there are quite a number of uses, so you can think of other uses. Then he's saying give one use and one effect of ethanol found in beer. So one use, it is used as disinfectant, but the effect is that it causes so the effect of the beer that is found in alcohol, ethanol that is found in beer, or if it's taken as beer, it damages the liver. Okay, damages the liver, and of course some other effect that we can talk of. Okay, so quite a number of effects as well. So we get to look at some more effects here. Okay, up to question 18, the diagram below shows the apparatus used for converting glucose into ethanol. Okay, so glucose into ethanol. So this is the whole setup. This is the beaker with warm water. So the whole of this outside is warm water. Then the conical flask. In the conical flask, that is where you find the mixture. Now, just you to know, in the mixture you find what? Zymase, which is the enzyme, and of course Zymase and glucose. Of course, say in the glucose mixture. So that is what you find there. Now, this warm water here, I'm sure it's at a temperature of 37 degrees, because the temperature here inside should be 37 degrees. So this water outside here is just here to maintain the temperature, or to keep the required temperature, which is 37 degrees. And here we have lime water. Okay, and you know the purpose of lime water is to test for carbon dioxide. Okay, so lime water is there to verify that yes, the reaction has occurred, because when the reaction has occurred, carbon dioxide turns lime water milkish. So just for you to know, the purpose of lime water here is just to verify that the reaction has taken place, and that can be seen when carbon dioxide is produced. Now, what are the questions that we are going to answer? What is the name of the chemical process? So the whole chemical process here, it is called fermentation. The whole chemical process is called fermentation. Okay. Then now, name the two other substances present in the mixture in the conical flask. What are other substances present in the mixture in the conical flask? So, what is present, other things that are present there, you find water and the enzyme. Okay, that is what you can find there, aside from glucose. So the other one is glucose, but glucose is mentioned, then they are saying other aside from that. Okay, then now state two necessary conditions needed for the process to take place. So I've explained quite on the condition, but anyway, can just give. So temperature of 37 degrees. So when you are writing, write in full temperature. Okay, let me just write it. Temperature of 37 degrees Celsius. What else? Zymase, a catalyst. Okay, then what else? Also absence of oxygen. Absence of oxygen. So these are the conditions needed for fermentation to take place. What is the function of lime water? So I've explained to test for carbon dioxide. Okay, and this verifies that the reaction has taken place. So test for carbon dioxide, or presence of carbon dioxide. Write the balanced chemical equation for the reaction. So the reaction that is occurring, okay, write the balanced chemical equation for the reaction of carbon dioxide with water. Okay, I mean lime water. So this was write the balanced chemical equation for the reaction of carbon dioxide with what? Lime water. That was the question. Write the balanced chemical equation for reaction of carbon dioxide with water. Carbon dioxide with lime water. Now lime water, you are aware that is calcium hydroxide. Okay, calcium hydroxide. So if you react it with carbon dioxide, it's going to form calcium carbonate, then plus what? H2O. Okay, so this is liquid, this is gas, this is aqueous, so which means even this one is in aqueous state. Okay, so this is what is going to form. Then how is ethanol produced in the reaction above separated from the mixture? So like I said, the mixture is water and alcohol. So the question is that how is alcohol separated from what? Separated from water. Now one thing that you should know is that these have different boiling points. For example, alcohol boils at 80 degrees Celsius. This one is 100 degrees Celsius. So due to difference in boiling point, the method effective for this is fractional distillation. Okay? Fractional distillation. So to answer the question how is separated, through fractional distillation. Okay? Because it uses the property of different boiling points. State the two uses of ethanol. So we've given already some uses at some point. Say it used as disinfectant. Then what is the other use? It is used as fuel. Okay, it is used as fuel for lighting and heating. For heating and lighting. Okay, so let us look at question 19. So for question 19, it's coming from 2019 school certificate. And the question reads, Elena used apparatus or the apparatus shown below to determine the energy released when ethanol burns. Elena used the apparatus shown below to determine the energy released when ethanol burns. So this is the apparatus. You can see the thermometer, the conical flask, and of course ethanol inside there. Okay, so what are the questions that follows? Okay, so the first question is that draw the displayed structure of ethanol. So let us do it quickly. We've been drawing ethanol all along. So ethanol, you know that it has 2 carbon, okay, with a functional group, that is OH. Then here connected to 5 hydrogens, that is with 2 carbons, like this. So this is the displayed structure. Then the second question, write the balanced chemical equation for the complete combustion of ethanol. So also this one is not the first time we are doing this. So ethanol, which is H2, 5OH, in the presence of oxygen, complete combustion by the way, so which means in full supply of oxygen. This one produces carbon dioxide, of which 2 carbon dioxide plus 3 hydrogen or water molecules. Okay, so this is the complete combustion of what? Complete combustion of ethanol. Okay, now the question that was B1. Now B2, when 4.6 gram of ethanol is burnt, 5.5 gram of water is formed. Calculate the mass of water formed when 13 gram of ethanol is burnt. So here you just form a ratio of ethanol, okay, ethanol to what? To water. So we are saying 4.6 of is it gram? Yes, gram of ethanol is burnt. Here it produces what? 5.4 gram of what about 13.8 gram what will be the mass. So here you just cross multiply, and you are going to multiply 13 multiply 5, then 4.0, so 4.6 gram x, that is x here, equal to 5.4 multiply 13. It's going to give you 74.52 gram. So here 4.6 gram divide 4.6 gram. So here x is going to give us 16.2 gram of H2O will be produced. So that is how we work this one out. Hydrogen is said to be clean fuel. Explain what it means. So hydrogen is said to be clean fuel. Explain what it means. So what it means that hydrogen is said to be a clean fuel, it is because when it burns, it does not produce pollutants. Okay, so when it burns, it does not produce a pollutant. That is what it means. It's a clean fuel. So when hydrogen burns, does not produce pollutants. So that's why it is a clean fuel. Okay? Up to question 20. State the meaning of the term polymer. State the meaning of the term polymer. So a polymer is just a large molecule. So let me write. Is a large molecule produced when smaller molecules called monomers joins. Okay, and of course there are different types of polymers that we are going to look at. Okay, and the process is called polymerization. Name two nutrient polysaccharides. Name two nutrients polysaccharides. So nutrients polysaccharides, we have proteins, we have carbohydrates. These are nutrients polysaccharides, and we can add fat, or can say fats or oils. Of course, these contain fat acids, okay, and glycerol. Name the common unit for polysaccharides. Name the common units for polysaccharide. What is it called? Okay, name the common unit for polysaccharide. Now, polysaccharide is coming from the word monosaccharides. Monosaccharides means means sugars. So when these join, a lot of them, since we said a polymer is a molecule produced when smaller molecules join together, called monomers. So this is the monomer called monosaccharides. When they join, they form what we call polysaccharides. Now, in this case, the name of the common unit for polysaccharide, which means it's a monosaccharide. Monosaccharide. Okay? And the monosaccharide, the smallest monosaccharide is, a monosaccharide is glucose. Okay? That is the one that we can look at. So the answer here is glucose, which is called monosaccharides generally. Okay. Show how the monomer unit are bonded when forming the cellulose using only 4 monomer units. Okay. So the monomers of that is glucose, it is represented like this. So here there's hydroxyl group, and of course even the other side there's a hydroxyl group. Let me draw it nicely. A hydroxyl group like this. So bonded to this. Okay. Then also another one, since they are of the same, so another one, they are saying we show 4. So let us add another one Okay. How many are remaining? 1, 2, 3. So we are remaining with 1. We add yet another one. So I'll try to shorten this one just for the sake of space. Okay, so after they've been joined all this, what happened is that one of these contribute HO, the other one contribute what? Hydrogen. This is condensation, so in all the linkage, water molecule is formed. Okay, in all these linkage, water molecule is formed. Okay, so water molecule is formed. So water molecule is removed. So even this side, the joining is happening. So the way it is going to be presented, this one is going to be like this. So here we can just leave this part like that. Then something like this. How many are they? 4. So we have how many? 3 of them now. Okay, so they are going to appear like this. Now, for the sake of differentiating them, we are going to put these like this. Then also this one like this. Okay, so that is how it appears. And this bond here is called glycosidic bond. That one is called glycosidic bond. Okay, let us look at if we have some more questions. State the name of the bond between the monosaccharides or the monomer units. Okay, we've already given it. It's called glycosidic bond. Okay, it's called the glycosidic bond. Name 2 synthetic polymers that are used in making of cloth. So what are the 2 synthetic polymers? So 2 synthetic polymers, we have what we call terene. Okay, this one is the trademark for polyester because of the ester bond that is formed. Okay, then the other one is the nylon. So what you need to write here is that's nylon and terene. This one forms soft cloth, this one hard cloth, but all in all used in making clothes. Which of the polymer you have named above is similar in structure of protein or with protein? So here is nylon. Okay, so the one that is similar with protein is nylon because for it forms a amide linkage. There is amide linkage. It's the one that join it. Okay, it is between the amine group and of course the carboxylic group, that is carboxyl group, and of course they form what you call amide linkage. Okay, so let us answer question 21. So for question 21 is that question 21 is coming from 2016, that is question 12. This one I extracted from 5070 paper 2, that is pure. The structure below shows an ester or structure formula of an ester is given below. The question is describe how the above ester can be prepared in the laboratory by naming the reagent and the condition needed for the successive reaction. So this one can be made by reacting ethanoic acid and propanol. Okay, in the presence of concentrated sulfuric acid. Okay, so in the presence of concentrated sulfuric acid as a catalyst. So sulfuric acid is the catalyst that is used in the presence of concentrated sulfuric acid to produce ester plus water only. Okay, so these are the products that are produced. So that is how we can write it, by reacting the ethanoic acid and propanol in the presence of concentrated sulfuric acid to produce esters. Okay, then pyrrolene is a polyester formed from carboxylic acid and alcohol units. Name the 2 monomers used to make pyrrolene. So the 2 monomers are hydroxyl, or the one that contain hydroxyl group, and carboxyl. Okay, carboxyl, otherwise written as this. So it has the carboxyl group. Okay, so here they're saying structural formula of pyrrolene showing 4 monomers. So I'm going to start with, okay, so for this one is going to be the hydroxyl. So joining, okay, then plus the carboxyl. We are going to join this one plus okay, the hydroxyl plus another carboxyl. So please just allow me to utilize the space that is available. So I'll put these lines for hydroxyl, then carboxyl remains like this. So in terms of drawing the diagram, it's going to appear like this. So what happens normally is that at this point, at this part, this one contribute the OH, this one contribute the O, and of course it forms the linkage. And of course also this one, it becomes like this. Okay, no, this one is the one that is, since this one is the, so the whole of this, and of course this, then here this. Okay, so now when it attaches like that, it's going to appear like this. So for here I'll just put something like this. Then this one will attach to this like this. Okay, then also attaches this one. Is it the shaded one, or the first one shall also be shaded one? Okay, this one. Then again the shaded one. Now we have another one, so it goes to the end. Also it has, okay, I guess so it's supposed to be something like this. So it connects there, so you can connect there at the end. You can just connect it and put something something like this. So you connect it there. Okay, you can finish it from the end there. So it's supposed to appear like this. So this side also we can put okay, so it remains like this. Okay, so this is how it can appear. Okay, so this is how it will appear. So please, I said finish it at the end there. There's a subunit, we said 4 of them, so it's supposed to appear like this. So you just join these. Okay, and this linkage in between is the one that is called Ester linkage. So sometimes you might be asked to write the Ester or to draw the structure of Ester linkage. So it's like this. Okay, something like that. Then of course let us go to this question, that is question 22. Propanoic acid, which is this one, is the weak acid. Explain what the term weak acid mean, or what explain the term weak acid. So weak acid is the one that easily ionizes in aqua solution. Is the acid, I mean that partially ionizes in what? In aqueous solution. So that is what we call weak acid. So weak acid is the one that partially ionizes in aqueous solution. Propanoic acid and that is B of 22. Propanoic acid react with potassium carbonate. Write the balanced chemical equation for the reaction. So now, in general, the acid react with the base. Then what is produced? Carbon dioxide and water, then with a salt. So potassium carbonate react with propanoic acid. Okay, now you know that propanoic acid is written like this: CH3 CH2OOH, then plus potassium carbonate written as this. Then generally when a carbonate or metal carbonate react with an acid, what is produced is a salt. So in this case, the salt that is going to be produced is potassium what is this? Propanoate. So potassium propanoate. So it's going to be C, not like this, CH3 CH2 COO. Then it is going to be like this. That is potassium there. Okay, let me just write it nicely. That is potassium. Then plus carbon dioxide plus water. But is this equation balanced? So to balance it, you can put a 2 here and you can put a 2 here. So this is propanoic acid plus potassium carbonate produces potassium, that is potassium propanoate plus carbon dioxide plus water. Question D is terylene has the simplified structure as shown below. So terylene has the simplified structure as shown below. State the functional group of the monomer used to make terylene. So what are the functional group? So the functional group used is the hydroxyl and carboxyl. So these are functional group used in the formation of what? Terylene. State the type of polymerization that occur when terylene is made. That is condensation polymerization, because water is removed in the process. Condensation polymerization. So that is the kind of polymerization. Many problems are caused by the disposal of plastics. Describe one method of disposal of plastics and problem caused. So one method of disposal of plastics, you can talk of burning. So you're saying these plastics are very difficult to dispose, but one method is the burning. Now what is the effect? It causes air pollution. So it causes air pollution. So that is one effect. Okay. Then question 23. Both fats and and proteins are natural polymers. Name the synthetic polymer that has the linkage as that of 1. Fats. Okay, so both fats and proteins are natural polymers. Name the synthetic polymers that has the linkage as that of fats and of course protein. So for this one is terylene. Then this one is nylon. Okay. Then what is the question? Draw the type of linkage found in the synthetic polymer made in 1 above, that is fats or terylene above, and name the linkage. So the linkage is like this, and of course this part I think I've explained at some point how to write this one. So the linkage is this one. Okay. And what is the name of this linkage? This is called Ester linkage. Ester linkage. The synthetic polymer are non-biodegradable. What does it mean, non-biodegradable? So they cannot be easily broken down. Okay, they cannot easily be broken down by bacteria. In short, they are difficult to dispose. Okay, that is what it means, non-biodegradable. They cannot be disposed of by the biological means, that is bacteria. So the bacteria cannot break them down for disposal. The structure displayed below is for another natural polymer. Name the polymer. So this structure is for another polymer. What is the name of the polymer? So the polymer is carbohydrate. Since we are talking of natural, okay, carbohydrates. Then is this polymer an addition or condensation? So the polymer is the condensation, because during the process water is removed. So condensation polymer. Then give a reason for your answer. Okay, water is eliminated. Water is eliminated. During its formation. Water is eliminated during its formation. So that is the reason. Then draw the structure of the monomer used to synthesize this polymer. So the monomer, it is this one. That is the monomer used to synthesize this kind of a polymer. Okay. So now, the last question is, what type of linkage is found in the polymer? So what type of linkage is found in the polymer is called glycosidic bond or linkage. Okay, glycosidic bond. That is the one that is found between the polymer. If I were to look at this part here is called the glycosidic linkage. Then this one is coming from 2023, that is GCE. Ethene and ethane are both organic compounds. Compare how they react, if at all, with oxygen. So oxygen, it has to do with what? Combustion. So they both undergo combustion reaction, and of course produces carbon dioxide and water. That is in plenty supply of oxygen. But in limited, they produce carbon monoxide and water. In short, they both undergo combustion reaction. So for oxygen, they both react. Then now, write the balance, compare how they react, if any, with oxygen. So the first one, I said they both undergo combustion reaction. Then the second one, hydrogenation. Okay, so only alkenes undergo hydrogenation. Okay, hydrogenation. To form what? To form alkanes. But for alkenes, they are not reactive with when it comes to hydrogenation. Write the balanced chemical equation for any of the reaction in above. Okay, so for any of the reaction, so I'm going to say ethene, which is H2, then here 4. Is it 4? Ethene, yes. 4. When it reacts with oxygen, it undergo combustion reaction. What is produced is carbon dioxide. In this one, we are going to assume is plenty supply and water. Now, if we were to look at this, is the balance equation. Here you have 2 carbons. Here you have 1 carbon. What about hydrogen? We have 4. So hydrogen 4 here. Oxygen is 4 because I've put a 2 here. Then carbon still remains 1. Let me put a 2 here. Carbon 2. Oxygen number has changed to 2. That is 4 and 6. So let me put a 3 here. So this is the combustion for what? Ethene. Okay. So end of the reaction. So what is the main you can write for hydrogenation, of which we've done already at some point. So you can write for hydrogenation of ethenes, or alkenes, and also you can look at the combustion for alkanes, of which we've looked at some point. So I don't think there's a problem on this one. Just draw the structure or display structure of ethane. So ethane is drawn as this. It has 4 carbon. Then for ethene, it has 2 carbons, a double bond in between, hydrogen, hydrogen there, hydrogen, hydrogen. So this is the ethene. This is the okay, so this is not this is methane. So ethane is like this. Okay, ethane is like this. Let us go back on this one. Okay, there was no displayed structure. Okay, so they are like this. So this is the ethane. Describe the chemical test that can be carried out to distinguish ethane and ethene. So what chemical test can be carried out between these two to distinguish them? So add bromine solution to both alkenes and what? Alkanes. Now how do you distinguish them? The result will be that alkenes which is ethene will decolorize bromine water. Okay, so in short, alkenes, when a bromine water solution is added to it, it decolorises it. So it decolorises bromine water. So that is the test that would be carried out. In other words, you can say using bromine solution. So using bromine solutions, alkanes decolorize bromine solution or water, whereas alkenes are non-reactive and therefore they will have no effect on bromine water. Okay, so basically this is where we wrap up everything. Okay, this is where we wrap up everything. So thank you very much for staying up to this point. So kindly subscribe to my YouTube channel and invite some more people to come to this channel. Make sure you give it a like, okay, and of course leave a comment if at all you enjoyed the lesson.